Oh, wow, I guess we're live. Good morning and hello. Or, the way that Cassie says, what's up, nerds? And I hear myself, oh God. Okay, wonderful. I don't hear myself anymore, which is absolutely great. So, hello, and, wonderful that you're joining us on this fine day at Death for Ukraine. This today will be the backend track, and I know we're a bit early and the timer was a bit late, so I'm going to do a chit chat with you. Isn't that amazing? But yes, hello everyone. So I can see we already got people from all over the world checking in. So got a couple of people from Berlin, which is nice because it's a wonderful city. But we also go to the US, and of course, one of the things that amazed me the most, sort of like how many watchers we had from Ukraine last time, which is amazing. I can't imagine being in that situation and then tuning in to watch this, but hello, you're welcome. And of course, this is to support all of you. Also, this is my first appearance as a streaming star. So you are watching the premiere live here, which is nice. Oregon, Mexico, Florida, nice. St. Louis, MO. I do not know what MO is. I would guess Montana, but you can correct me. Missouri, damn. So my homework is to learn all of the US states and know how many there are. That, yeah, is going to happen. All right, we hope New Zealand, you're the king or queen or the emperor of this entire thing, because you're getting up at like what, 4 or 5 in the morning or whatnot to watch all of this. So like you have my deepest respect and regards. I'm not sure if it was you or somebody else from New Zealand that was also here yesterday for the Fronted Day, which was amazing, by the way. Like, if you haven't seen it yesterday, go watch those talks. They're on our YouTube, and man, there were some mind-boggling ones. I mean, my favorite was the one for Volodymyr, for many, many reasons, because he just made the visualizations so great, but he also had this sort of like deeply impactful personal story with, how he's living and how his life in Ukraine is right now, which was, just straight up amazing. And yes, we're not just here to talk and to sort of like chit chat. All of this, has a purpose. And that purpose is to help people in Ukraine. And for that, you can donate. And these days we got a nice little bot that says ka-ching every time you donate something. And, I'm hoping to hear a lot of ka-chings today. And, I hope that we're getting over that 100K mark, which we set as our goal. Which, if we donate nearly as much as our front-end friends yesterday, that should be easy. And my video goes blurry because my webcam, which costs 250 euros or dollars, absolutely hates me. Isn't that wonderful? I knew this was gonna happen, but I thought it would be after I showed the bunnies. Well, this is life. I can try to make it focus again, but it also sometimes comes back by itself. Wait a second, webcam. No, okay. Webcam. No, maybe. Okay, we will have to live with this for now. And oh no, now I'm back. Cool, very sorry. Yes. Okay, what's the time? We're 2 minutes over, so I think let's wait until 3 minutes because that's what the countdown was saying. Thank you, Fry Guy. Very good. Oh, Pablo, thank you. Yes, Sharp Toby is to wow, $100. We cracked 98K. Yes, that's what I was saying. Only donate half as much basically as our front-end friends did yesterday, and we'll be at 100K in no time. And so let me do the intro. I think it's intro time now. So let me just move this over here. So welcome everybody at Death for Ukraine, which is this amazing event. Today is the backend day, And we just got a few things to run through. So Cassie, Q, yes, of course you knew. I didn't need to tell you. I'm very sorry. I'm a slight bit nervous, but it's okay. So you can go and donate at that's4ukraine.io. We have a code of conduct, as sort of like every event worth its salt has, which you can find online at the URL displayed. And I'm sure some helpful people will also post in the chat so that you can just click on it. If you have, questions, the chat is cool. Like, chat was really, really awesome yesterday, and I'm very sure that chat is also going to be very, very awesome today as well. The videos are going to be recorded. They will be up on our YouTube. It's actually streamed there directly right now. So for us, it's cool if you come in like here and hang out with us in the chat. But if you really want to, you can also go over to YouTube and sort of like watch it back. And so, yeah, today we're at day 2, which is the backend talks. It is, doing backend is also, because there's so many technologies and we kind of threw this together so fast that we kind of had to bias it to sort of, let's say, what I like, like where I came from, so the people that I know. So we're going to have like a bit of a focus on Ruby and Elixir, but the other topics that we're covering will also be startups and open source. So this is sort of what you can look forward to in the evening. We have a schedule up online, but basically first we're going to have Ruby talks, then startup, then Elixir, and then open source. Yes. And I really, really want to say thank you to all of our speakers who also, got all of this last minute. We were like, hey, can you give a talk? They were like, I'm so busy, but yes, it's for good cause, so I'm going to do it. Amazing. And so they all did this. So they all also deserve our love and respect. And speaking of love and respect, some of that naturally also goes to our sponsors, which are, companies that sponsored a big amount of money. And so let me go through the list here. So that means thanks to Frontend Masters, OSS Capital, Incredible, Linode, Akami, Stripe, and Remote or remote.com, which is not as a sponsor on the website, but it's sort of like helping us run this. So we all work there, and so we can volunteer our time. So I will also use this time to thank my co-organizers, especially Sarah Vieira. She came up, like you can see her in the chat, as Nikita for the world or for the win, I'm not quite sure. And she came up with the entire idea. She got us all together to run this thing. She built a website and everything. So none of this would have happened without her initiative. So she really deserves the utmost praise for this wonderful event. No, you bully a little bit. No, I'm just joking. It was wonderful. And then, of course, you saw Cassie today, and Cassie's also our producer today. And I can just say it was lovely working with both of them on this. So I never regretted my decision to do this. And then we also have Marcelo, our CTO, who also helped out with the talks and some of the infrastructure, and Adrian, do I pronounce that correctly? Yes, who did the designs and everything. Okay, that is, I think, enough of an intro, or well, almost. Like, I can see many comments on the suit, and so if people know me, they're like, wait, what, Toby, why aren't you wearing like a band t-shirt you've owned since you were 16 or something? And why isn't it green? And also, who are you? And what did you do to Toby? Common questions that I receive currently, apparently. And I don't know, for me, this is a fundraiser for an event that I'm, not for an event, for a course that I'm really, really passionate about. I'm going to tell you more about that today. And so I felt like, this is a fundraiser. Let's bring out fancy Toby. I think I've never been sort of like, never dressed as fancy. I never had this. I just know the German word Einsteck too. I'm sorry, somebody will have to translate it in the chat. And also, if I'm not mistaken, blue and yellow, if you mix them together, they are green, So technically, I'm still wearing green if you just, blur the colors fast enough. And I love all of these kachings. Wonderful. So then it's really time to get rolling and not more talk about why Toby is looking so fancy and liking it. Maybe later. So our first talk of the day is, I would say the developer I look up to the most. So I'm extra happy and grateful that he, volunteered to give a talk here. His name is Aaron Patterson, Tenderlove. He is Ruby core, Rails core. He does so much amazing open source work. He's just incredible. He's famous for his puns. I'm sorry, I'm not famous for my puns, so you will miss out on that. But yeah, I think you will maybe get an overdose from Aaron in this first talk, and then later it will be fine with me not doing as many puns. His talk is about Jit compilation, and basically he's looking at it like, hey, this is the stuff that I would have wanted to know 4 years ago or 3 years ago when I started writing Jit compilers and everything. And so this will be a great talk. So I hope you all enjoyed. Keep donating, keep having fun, and cue the video.
Hi everybody. Before we get started, I need to get a little bit of help with my green screen here. Hold on a sec. Okay. Thank you. Hi everyone. Welcome to my presentation. This talk is called Almost on Time. It's about Jit compiler basics. My name is Aaron Patterson. I'm also known on the internet as Tenderlove. You can find me on Twitter or GitHub under that name. I work for a company called Shopify. I'm on the Rails infrastructure team. We're a pretty researchy team. We focus on performance of Ruby and Rails. We've been working on a Jit compiler called Jit for Ruby. But yeah, that's what I do. I'm really excited to be speaking at Devs for Ukraine. I'm really happy to be here, and I'm so thankful that you all would have me. And I want to say thank you to everybody that's watching this, especially if you have donated. So please donate. So a little more about me. I'm on the Rails core team. I'm one of the folks on the team that's responsible for the Ruby on Rails framework. I do work on the Rails framework itself. I've been on the Rails team for maybe 10 years or so. I don't remember how long exactly. I'm also on the Ruby core team as well. Our team is responsible for doing Ruby development or developing the Ruby language itself. I bring this up because I want to say I really, really love Ruby. I love the Ruby programming language. I think it's really, really great. But today I don't really want to talk about the Ruby language so much as today I'd really like to talk about JIT and JIT technology. And there's definitely going to be Ruby in my examples. I'm going to put Ruby in the examples, but I hope that the things we're going to talk about today will be useful in many different languages and not just Ruby. I tried to design this talk to be as if it was for me or something that I wanted some years ago. I think back on there was a time where I thought to myself, JIT seems super cool, but how do I even get started on writing one? And I couldn't really find good tutorials online, and I wanted to write this presentation as if I was giving it to myself a few years ago before I knew this stuff. So I hope that it will be helpful for people like me who don't really know what JIT compilers are or how to even get started writing one. So let's get into it. What is a JIT compiler? I think is a basic question that people wonder, and the answer is quite simple. A JIT compiler is something that can assemble machine code and execute it at runtime, and that's pretty much it. That is it. If it can put together machine code at runtime, it is a JIT compiler. And I think a really interesting example of this is metaprogramming in Ruby. We can think of a JIT compiler as very similar to metaprogramming. So in this example of code, we're creating methods at runtime. We're creating Ruby methods at runtime, but instead of creating methods, we're actually going to generate machine code and execute that machine code. So rather than making methods, we're going to make machine code, and I guess that would be the difference, is that a JIT will make machine code. And the interesting thing is, this isn't specific to just one particular language. You can write a JIT compiler in any language that you want to, as long as you can put together bytes into a string. If you can put bytes into a string, you can write a JIT compiler in that language. But today, we're not going to be writing out just random bytes to a string. I mean, maybe that would be helpful for cryptography or something, but I don't think it's going to be super helpful with a Jit compiler. So we're not going to just write out random bytes. Instead, what we're going to do is I want to take Ruby code and I want to convert that Ruby code into machine code. So how do we get there? Like what, I think the first question that we need to answer is, what kind of tools do we need in order to do this? And I think that there are like three basic things that we need, only three basic things we need to write a Jit compiler. The first one is we need a way to allocate memory. So we need some method for allocating memory, and it can't just be any memory, it has to be executable memory. So we need a way to allocate executable memory. The second piece of the puzzle is we need a way to assemble code or assemble machine code and put it into this executable memory. And the third thing that we need is we need a way to actually jump into that executable memory so that we can execute it. It's not good enough to just assemble the bytes together. We have to be able to jump into those assembled bytes and have the machine actually execute those assembled bytes. So for allocation, I wrote a gem called the Jip Buffer Gem. Right now, it only works on Mac OS. Like theoretically, theoretically, this gem is supposed to be a cross-platform Jit buffer object, but right now it only works on Mac OS, and that's because I just haven't done the work to make it work on other platforms. But it should work fine. We just need to do the work for those platforms, which I will do at some point. But yeah, this is an example of using the Jip Buffer Gem. Basically, we just create a new buffer of a particular size. We mark it as writable, and then we can write any data to it that we want to, and then we can mark it as executable again. And it works like, you can treat it just like an I/O object. The only difference is that this I/O object is working with executable memory. And because of system, like the writable and executable methods are kind of weird, but we need those because of system level protections. So like Mac OS and other like BSD, those operating systems won't allow you to have memory be executable and writable at the same time as a security precaution. So you have to either be writable or executable. You can't be both at the same time. So I provided methods for you to toggle between the two. So the next thing that you need is an assembler. And we have a couple choices here. I wrote one gem called ARH64, which is an assembler for ARM64 processors, or FISC, which is an assembler for x86 processors. So you have to select the one that you're targeting for the platform that you're targeting. In these slides, I'm going to be using the ARH64 gem, and that's because I'm on a Mac, and it's an M1. It has an ARM64 processor, and that's what I've been working with. Here's an example of using it. In this example, we're just putting together two instructions. It's the mobz x0. We're putting the number 42 into the x0 register, and then the second instruction, the ret instruction, is just saying, hey, I want you to return from this subroutine. So we're putting 42 into the return location, and then we're saying, hey, please return from this subroutine. And then we can ask the assembler, like, hey, can you write yourself out to this buffer? So we can hand it a buffer. The buffer could be a string, or the buffer could be a file. But actually what would be really more useful is if the buffer is our Jit buffer, and that's the next example here, is we take that assembler, we combine it with the Jit buffer, and then we ask the assembler, hey, write all of those bytes into the Jit buffer. So we have two of the things that we need, and the third thing we need is a way to execute this memory. So we have our bytes written to memory, and we'd really like to execute it now. The way we execute it is with a gem called Fiddle. It is another gem that I wrote. It ships with Ruby, and it's just a libffi wrapper. And I want to show an example of calling a function with Fiddle. In this case, we're calling the strlen function, and we need to, first we get the address of the strlen function, then we create a function object that wraps the strlen function. And to make that function object, we have to provide three things. We give it the function address, we give it the parameter types, in this case a void pointer, because it's a strlen, we're measuring the length of the string, and the return value, we have to say that it's going to return an integer. Now, what's really interesting about this is, I said earlier, we're giving this function object an address, we give it an address to jump to and execute. And what's kind of cool is that fiddle / libffi don't really care, like they don't care what that address is, they just jump to that address and start executing it. So we can give it any old address that we want to, and what we can do is we can say, hey, I want the address of that executable memory, that Jip buffer. I'd like you to jump into that Jip buffer rather than the strlen function. So here's an example of all three combined. We have the AR64 gem with the Jip Buffer Gem with fiddle. So we put all these together. First we assemble some machine code. We say, hey, I want you to execute or create these this machine code. We write that machine code out to an executable buffer. We create a new fiddle object where we say, hey, I would like you to, we create a new fiddle object and we give the function object the address of the executable memory. And finally, we just say, hey, I'm going to call you. I want you to jump in and start executing. So if we look at the machine code that we assembled, we see, hey, we're moving 42 into the return register, and then we're just returning. And you can see when we call the function with func.call down at the bottom, it gets the number 42 back. So we were able to successfully put together machine code at runtime and execute that machine code all at runtime. So we can say that this is our first JIT. So we could take all that stuff, put it together at runtime, and execute it. We've checked all the boxes for what is a JIT, and we did it. But there's kind of a weird thing if you look at this code. Like, here's an example. Like, here's the code that we wrote at the very top of the script. If I were to write this code in assembly language, like if I were to write an assembly language script, it would look like this. And it's true that, yes, indeed, we did write pure Ruby. That's really great. But this pure Ruby looks very, very similar to assembly code. And I don't know about like you, but do you want to be writing assembly code? I certainly don't. No, we don't want to be writing assembly code. Rather, what we'd prefer to do is have like some sort of translation process where we give some function. We say, hey, I want you to take this Ruby code and I want you to convert this Ruby code into machine code for me. So it'd be nice if we had some way to like translate the Ruby code into machine code for us automatically. And that's generally what we think of as a JIT. I guess more advanced JIT. So I want to talk about this translation process because I want to take some Ruby code and I want to convert that Ruby code into machine code. And honestly, the basic idea that we're going to walk through here doesn't have to be, like, it's not limited to just Ruby. We can do this with any language that we want to, but I'm going to use Ruby as the example here. And you might be thinking to yourself, oh, we're gonna have to write a parser and compiler for Ruby. And the answer to that is no, we are not going to do that. And the reason we are not going to do that is because it is way too hard and I am way too lazy. Ruby has a perfectly good parser and compiler, and we can leverage those instead of writing our own. And the output of that parser and compiler is actually Ruby bytecode. So what we would like to do is instead of like taking all the complexities of the grammar of the language and compiling all that, instead what we'd like to do is take the simple machine instructions, the bytecode, and write a converter that can take that bytecode, convert that bytecode into machine language. So to do that, we need to know a little bit more about machines. So I want to talk about the two different types of machines that we have to deal with today. There's two different types of machines that you'll encounter, and those are stack machines and register machines. And stack machines are pretty popular for virtual machines. That's because they're very easy to implement in software. Register machines are very common for hardware, but you'll see them, they're common for hardware because they're easy to implement with hardware, but you'll also see register machines in virtual machines as well. So some examples of stack machines, Yarv, which is the one where Ruby's virtual machine, that's the one that we're going to be messing with today. It's a stack machine. CPython uses a stack machine. Sun's JVM also uses a stack machine. Examples of register machines, the V8's virtual machine uses a register machine, and your ARM processor or your Intel processor, the x86 processor, those are register machines, but they're examples of hardware register machines. So let's take a look at how stack machines work. So we need to understand how the stack machine works so that we can take Ruby's stack machine and convert that into the machine code, which into a register machine, which our hardware actually uses. So if you've ever used an HP calculator, this will be very familiar. There's probably like, I don't know, maybe two people watching this that have used HP calculators. I used an HP calculator in high school and I loved it. But if you've used one of these calculators, you already know this process. But basically, Ruby, what it does, it takes your source code. When you run a program, it takes your source code and it converts that source code into YARV instructions. And the virtual machine will execute those instructions. Those instructions manipulate a stack. And here's kind of an example. Say we have this function adder. This function adder gets converted into these compiled instructions. And I want to run through these instructions so we can get kind of an idea of how they manipulate the stack. After they've been converted into, or the code's been converted into instructions, the virtual machine will interpret them and manipulate the stack. Now there's two important components of the virtual machine. The first one is the program counter, or the PC, which you see in blue here. The program counter points at the next instruction that will execute. And then we also have the SP, or stack pointer, and that points at where we're going to write to next. So when we execute an instruction, or when the virtual machine executes an instruction, first it pushes the PC forward and then executes whatever it was on. So in this example, first we'll push the PC forward, then it'll execute the put object instruction, which pushes a 3 onto the stack. Next, we'll do the same thing. We'll push the PC forward. This one pushes a 5 onto the stack. Then the next thing we'll do is we'll execute the plus instruction, and the plus instruction is a little bit different. It pops 2 values off of the stack, adds them together, and then pushes the return value back onto the stack. So when we execute this, it'll pop 5, pop 3, and then it'll push 8 again. Then finally, the leave instruction will just return whatever value is at the top of the stack, it just returns that. So we can think of the stack as kind of an infinitely long array. And it's very nice to implement, a stack-based virtual machine because we can just manipulate this infinitely long array. We just push and pop values on and off of the stack. It's pretty easy. Now we'll contrast that with register machines. Let's take the same code, same Ruby code, and imagine that we had a compiler that converted this Ruby code into machine code. The machine code might look something like this, where the machine code instructions are on the right. And if we kind of imagine how this is executed inside the machine, our computer also has a PC as well, and it does the same thing. It points at the next instruction that's going to execute. So in this case, we say, hey, I'm going to copy the value 3 into the X0 register. So first we'll push it forward. It puts 3 into the X0 register. Do the same thing here. We'll say we're going to put the number 5 into the X1 register. And then the add instruction takes 2 registers, and it says, hey, I'm going to take these 2 registers. I'm going to add them together, and then I'm going to clobber whatever was in the register on the left. So in this case, we're going to take X0, add it to X1, and then the return value of that is going to be in the X0 register. So when we execute this, 3 and 5 get added together, and then 8 is written into the X0 register. And an interesting thing is that the X1 register doesn't get cleared. Whatever value was in that register when we did the add, it's still going to be there after we did the add. So it doesn't actually clear any data out there. And finally, we just return. So to compare this with our stack-based machines, register machines have to deal with a fixed number of registers, and the instructions have to specify which registers they're manipulating. Now, stack machines don't have to specify registers because they know that they're just manipulating a stack. So you can kind of see how it's much easier to implement a stack machine. You can think of a stack machine as a register machine, but with an infinite number of registers. Unfortunately, real machines have a finite number of registers, so we have to deal with that. Now, we're going to do some conversion. Now that we know how both these types of machines work, we just have to write some code that performs a conversion from one type of machine to another. But before we can do this conversion, we have to somehow access the instructions that the Ruby VM uses. Fortunately, there's an API for doing that, and that's the Ruby VM instruction sequence class. We can take this class and say, hey, I want you to access the instructions for a particular method. in this example, we're disassembling the adder function, and if we look at the output, we see very simple, like it's very similar to the examples that we saw earlier. The instructions just say, okay, I want you to push 3 onto the stack, then push 5 onto the stack, then I want you to pop the 2 off and add the results. Then finally, whatever's on the top of the stack, I just want you to return that value. And we can actually get the instructions back as an array. We can ask this iSeek object. We can say, hey, can you convert yourself into an array, please? And I know that the output of this looks really, really messy, but you don't need to read it. It's not super important what's written here. The important part is that we can actually programmatically access these bytecodes or these instructions. And since we can programmatically access them, that means that we can write a converter. So to write a converter, we create a class which is called essentially a virtual stack. And this virtual stack, it maps the stack into registers. So here's an example of using it. The stack helps us convert the pushes and pops of a stack into machine registers. On the left is the implementation, on the right is the usage. When we push a value onto the virtual stack tells us what register we should write to. And when we pop a value off of the virtual stack tells us what register we should read from. So we can see that in action. Here's an example. At the top we have the VM instructions from our sample method, this adder method. Below we have a loop that processes each one of those instructions. And we use this virtual stack object to process them, pretending as if we're manipulating a real stack, when in fact the virtual stack is just telling us which registers we need to read and write from as we're generating the machine code. So to zoom in a little bit, let's take a look at this put object instruction. Here we say, hey, I want to push an object onto the stack. I want to push some value onto the stack. Where should I write that? And then we push that. The stack tells us where to write it. And then we tell the assembler, hey, I would like to write a value into this register. So we write to that particular location. Now, in the example of the add instruction here, we say, hey, I need to pop 2 values off the stack. Where should I read those 2 values? So we say pop, pop, and then we add the values together. So we add those 2 values together. And then finally we say, hey, we need to push the result of that onto the stack. Where should I write that? So we call push on the virtual stack, and then we write to the location. Finally, the leave instruction, we just pop the last value off the stack, put it into the special return register, and then we return. So if we run this code and disassemble the generated machine instructions, it'll look something like this. So on the left is our conversion function, and on the right is the machine code that we generated. Now, if we take this loop here and these processes and extract them out into a function, we can write something that looks like this, where we say, hey, I'm going to give you, we have this function called make function, and we say, hey, I'm going to give you a Jit buffer, and I'm going to give you a method object, and I want you to convert the instructions from the Jit buffer, or from that method object, into machine code and dump that into the Jit buffer. So taking exactly the code we saw on that previous slide, extracting it to a function, we're able to get this machine code back out on the other side and to execute it as well. So we've successfully been able to convert a Ruby, a regular old Ruby function, into machine code using pure Ruby. So we've written really our first real JIT. This is, I guess the previous JIT was also a real JIT, but this one's taking code that we would want to write. We want to write Ruby code, or we want to write Python. We take that code we want to write and we convert that code into machine code. Now, there's a few performance improvements we could do. For example, in this particular example, we wrote a really simple translator, and the thing is, we've got this machine code as output, but just because we wrote machine code doesn't mean that it's fast necessarily. So can we make this machine code smaller? And we actually can. You'll see there's 2 instructions here. When we do the add, we say, hey, I want to add, and then I'm going to write. So I'm going to add the 2 values, and then I'm going to write the result of that add to this virtual stack, which is actually a machine register. Now you'll notice on the ARM instruction set, most of the instructions take triples, so they'll take 3 registers. And what this is actually saying is, it's saying, hey, I want you to add x1 and x2, and I want you to write the return value of that to x3. What that means is, when we add stuff together, we can actually do the add and the write in one instruction rather than 2. So in order to support that, what we do is we refactor our plus handling code. When we do instead of doing an add and then a write, we say, hey, I'm going to pop twice to understand where we need to read the two values, and then I'm going to push once so I know where to write the result value, and then I add those together. So we say, hey, add, here's the write location, and I want you to write the addition of these two registers into that write location. So if we make that simple little change, we'll see that we end up with better machine code as output. We have one fewer instruction. The other thing that we can do is we can teach types to this virtual stack. Like in this case, we are pushing integer literals onto the stack. When we push those literals onto the stack, we can say, hey, virtual stack, I'm pushing an integer literal. So we'll push the int literal 5 and we'll push the int literal 3. And why would we want to do this? The reason we'd want to do this is because, for example, in this opt plus instruction where we're popping the two values off, we can look at the types and say, oh, you know, those types, those two are actually integers. They're just integers. So rather than doing rather than doing an add instruction, I'm going to do the add at compile time and then just do a write. So we can do the 3 plus 5 add at compile time, and we'll end up with machine code like on the right where we say like, hey, I just want you to write the number 8 into this register now. I don't need you to do an add. I'm just going to write the number 8. What's interesting about this is we're essentially doing a calculation at compile time, and we're caching the results of that calculation into the machine code itself. And this can get a lot more interesting when we're caching values of, say, like, I don't know, other computations, like maybe we want to cache an object's location, or computations of other things that we can understand at compile time. Now, another thing that we can do is, well, we know we're not actually using this 3 and the 5, those two instructions at the top. They're not actually necessary anymore because we compiled we calculated that add in advance. So we can remove those two writes. Now, there's some further challenges that I want to talk about here. Like we've been able to write a Jit compiler, and I want to talk about kind of the challenges like going forward. Like let's say we were gonna take this Jit compiler, we're gonna do it for real. We're gonna write a really great Jit compiler. One of the issues is, well, we only implemented 3 instructions. We implemented put object, we implemented plus, and we implemented leave. So we only did those 3 instructions. Unfortunately, in Yarv, there's 202 instructions. So if we're gonna support all Ruby code, we have to be able to support all of those instructions. But I mean, it's not such a big deal because not all Ruby code uses all instructions. So maybe only implement the most popular ones. But I think a more difficult thing is, what about weird code? So let's take some weird code. For example, let's say we have an adder function like this. We say hey, we're going to do a 3 plus 5. We're going to convert that into machine code. And when we do that, after we've converted it into machine code, somebody monkey patches plus. Now we have to say, hey, machine code, I need you to be invalidated. How do we deal with this? So, all right, so let's wrap this up. We talked about what a JIT is, along with the 3 basic parts required to write one, which are, those 3 basic components are, we need something to allocate memory, specifically executable memory. We need something to assemble machine code together and write it into that executable memory. And then finally, we need to be able to execute that memory. We need a way to hop into it and let that executable memory run. We were able to write a basic JIT that just returned a number, so it just assembled very simple instructions and returned a number. And finally, we were able to write a very simple compiler which would take regular Ruby code as input and produce machine code as output. So I think, I really, really hope that by the end of watching this, everybody who is thinking, what is a JIT, has gone from, what is a JIT, I'm not sure what this thing is, to I can write a JIT. And even if you don't write a complete JIT, at least you'll still be almost on time. Thank you so much. I'm so happy I could be here and be part of this. Thank you for having me. All right, let's put this green screen away now. All right, thank you.
Thank you, Aaron. As always, this has been a pure joy and just, so much knowledge sort of like dropped on us in like a very understandable way. I really, really admire Aaron, and I hope you all had as much fun and tried to learn as much as I did during that talk. It's not sure if I'm able to write it yet, but once I'll watch the talk back and then watch it back again, because it will be on YouTube later for those asking, I may be able to actually go and write a JIT, which will be very, very cool and very nice. So before we go on with this program, I want to tell you a bit of story about like the last time that I saw Aaron in person, because while we try to make this a very fun and interactive event, right? We're here for a very discrete reason, and that is the war that is raging in Ukraine. And I try to keep a balance between being happy and reminding everyone of that. So this is, Aaron tweeted this out, this photo again, a short time after the invasion started. So this is a Pivorek meetup, and this is like a tweet. And this like a picture of like Aaron does these Friday hugs. And if you know how I normally look like when I don't dress up in the colors of Ukraine, you can find me on that picture quite easily. And this was an event there in 2019, beautiful mini conference. And I was also speaking at the same event, obviously before Aaron or like after Aaron, I don't know. Aaron was the main attraction, I'm just a side attraction. But let me tell you how I got there. I was, let's hope this works. No, that does not work, but does this work? This works. So this is the beautiful city of Lviv in the west of Ukraine. This is the central city hall, and I got invited by them even back in 2017 to come and speak at the event. And they're like the most fun and nicest people. And something that they gave me, everybody gets a t-shirt. And if you know me, I love my green t-shirts. I always wear green t-shirts normally. And I got a special Pivorek t-shirt, the only green one that exists, because they knew this about me. And this is one of my most precious possessions. And you'll also see it today because I wore it during the Q&A and the other stuff. So they were the most warm, welcoming people. Like also, I think first time people paid for my flight and, me staying somewhere. And so I went there. And I took with me this guy. I think you can all recognize the guy on the left. The guy on the right is one of my best friends. We've been friends for 14 years. He was actually born in Ukraine, in Kharkiv, in the east. And him and his family, so his name is Anton, they fled to Germany when he was about 4 years old. So that was the first time he was back in sort of like the country he was born in. And so I know someone who, has already fled Ukraine back in the day. And so Ukraine is really precious to me. This is us inside, him inside this town hall that you just saw from the outside. And you can see to the left is the flag of the European Union. And Ukraine is still not a member of the European Union. They just applied, so you can see like what these people want to go for. And in the middle, the Ukrainian flag, and on the right, the flag of the city, Lviv. And I was there for the second birthday of it. And so why am I showing you all of this? I want to show you, you all seen the pictures of the war. I want to show you the pictures of the happy times so that you can see that maybe what those people have lost. And so on the right there is Roman, who actually recommended me to go there. He is living in Berlin right now. And on the left is Anton and the fun second birthday of that amazing Ruby meetup. And let me tell you, I'm running the Ruby user group in Berlin, and that one is the best Ruby meetup with the best community that I've ever seen and experienced in my life. This is Anna. She runs the community, and she was just super awesome and all the time very, very supportive of everything. When I was there for the first time in 2017, we celebrated a birthday with a big cake, and they actually made me open sort of like a bottle of champagne, which I've never done in my life. So you can see me struggling there totally, and all of them celebrating. On the left, you can also see Oksana, who also organized the meetup. And here's Anna, Oksana, and Volo, I think we call him again. And, I think of all of these friends as, of all of these people as friends. And so it hurts my heart when I see what's going on in Ukraine. Although, Lviv hasn't been hit much, but it has been hit, and all of them have family. And so when we arrived, we asked them sort of like, what's up? And one of the first things that Anna said that they were all kind of disappointed that sort of the West and Europe forgot about the war that has been raging in Ukraine since 2014, because there was still war in the East, and how we all just go on, and like Crimea is still annexed. And so that's why I always say like the beginning of the invasion, because the war has been raging for a very long time. This particular thing is like the big graffiti in the city of someone from Lviv who died in the Maidan protests in Kiev. Speaking of which, if you go to Maidan in Kiev, where I went to in 2018 to speak at another conference, there's like a big exhibition with like information and photos from the Maidan protests. And there's a huge line next to the Maidan with the pictures of everyone who died fighting for this revolution. And so I always walk past that, trying to remember each and every one of them. So also in Kiev, you saw this guy Anton before. I met a lot of the P-Work people again. If you see like, oh, this looks like Drunken Toby having too much fun, I don't drink. I'm just genuinely so excited to see this guy, Anton. And, this is, I don't know, why I care so much about them and all of this. So I got back there. So they invited me back in 2019 on like a short notice. I got back in there. And like, as you can see, I'm having fun and time of my life again with Anna on stage. And I've been to, I have a favorite cafe in Lviv, which these are the pancakes that I ate there, and they're just amazing. And this time I went there with another very good friend of mine, Mr. Piotr Chatkowski, which was really, really good. So I always visit this place with friends. And so these are some of the photos that he took so that you can see a bit what this amazing, wonderful city of Lviv that I wanted to go to again. Every year, 2017 to 2019, and I definitely will go again. And yeah, so this brings us back to the moment where, Aaron started and said, like, give me a hug. And we took this picture, and there were many of these pictures. You can see all of these people there, happy, learning, being great in their community. And I'm sorry to be a bummer, but like today, I can't look at this picture without thinking how many of these people have lost their home, how many of these people need to leave their home, how many people of these have lost someone that they love, and how many might not be alive anymore. And it's a terrible thought, I know. So, while we can't stop the war or something, we can certainly do everything that we can in our power to make sure that people don't forget what's going on in Ukraine. And we can all also donate some money to help the people, fleeing this terrible situation and, searching for hope and, helping them with the best that we can. And so, yeah, this is a little bit of Toby talks about his relationship with Ukraine and going massively over time on everything. So we can cut that. Thanks, Cassie. And well, there's no good way to make this change of pace now, other than you donate a lot, and that makes me happier again. Next, we have somebody else that I'm totally excited about that we got her to speak, which is Sandy Metz, which is my favorite author of Ruby books. She wrote the absolutely incredible practical object-oriented design in Ruby, which, just reading one page about testing makes you 10 times better. Well, twice as good in testing. And, much like many of us, she was like, hey, this is too much. I don't have the time, but you know what? Actually, I do, because this is important to me. So she was a long shot. Like I was like, she's not gonna speak. She's gonna be too busy. But she did, and she will speak for us. She will talk about factories, and why and how to design them, open factories versus closed factories, which is something that I never heard before. So I'm really much looking forward to that talk. So please go and enjoy Sandy's talk.
Hi, I'm Sandy Metz, and this is If You Build It, They Will Come. And it's a talk all about object-oriented factories. Now, before I get into the talk, I just want to thank you for signing in and watching these talks here at Devs for Ukraine. You've already given a whole bunch of money, right? And told all your friends to watch these talks and give a bunch of money. I tell you, when I got the opportunity to be part of this, I just didn't want to do it because I felt so busy. And then I took a minute and thought about that, and I realized I was sitting in a house where I felt completely safe, and that the same thing is not true about our fellow devs in Ukraine. And it made my troubles, frankly, seem small. So if you feel safe, go to this URL and press that button and give them some money. It'll help. Now, I told you I was busy, and as a result, this talk is the conjunction of 2 sections of a video series I've been making for the 99 Bottles of Oot book. This is not an attempt to get you to buy the book or the video series when it eventually comes out. It's just to tell you that that's where this content came from. The first section stands alone. It doesn't require much context, so we'll just dive right into that. After this section, I'll jump back in and give you some more context so you'll have some idea what's going on in the examples being used in the second section. So, with no further ado, Fathoming Factories. This is section 7.2, Fathoming Factories. Object-oriented applications rely on polymorphism. Now, you might remember, maybe, that polymorphism is the word we use to refer to that quality where many different objects can respond to the same message. The power of polymorphism is that these different objects are all the same from the message sender's point of view. I'm going to show you some pictures that I've excerpted from my Go Ahead and Make a Mess talk. The entire talk is included as bonus material at the end of this chapter, so if you find these pictures useful, you might be interested in watching that whole talk. The premise of this talk was based on a software for a game. The game involved riding bikes. Players who rode bikes could buy parts. One of the parts they could buy was a shock. Since they had to pay for the shock, there was a calculation for cost, and that calculation was assumed to be some incredibly awkward, long, messy method to determine what a shock actually cost. As the game evolved, we needed to add more shocks. There were more different kinds of shocks that players could buy, and each of those shocks had its own messy, complicated calculation to figure out what that shock cost. Now, if it was your job to update the shock class so that it knew about all these different costs, you could break right into the cost method and put a big conditional. And the branches of that conditional could be all the different big, long, messy cost calculations. Or you could extract each of these methods, wrap it in a class, make each class respond to the same message, or another way to put that would be to have every class polymorphically conform to the same API. The interesting thing about doing things this way is if I have a bunch of classes that polymorphically conform to the same API, then senders of that message can forget about the types of the class. They don't need to think about these objects that they're collaborating with as kinds of their types. They can treat them instead as players of a role. Message senders don't need to know the name of the class. They just need to know the name of the message. And so the class effectively disappears. Message senders can confidently collaborate with these polymorphic objects in faith that they all honestly play their role. It thinks of them as not kinds of a type, but as trustworthy players of a role. From the outside, all these polymorphic objects look the same. Internally, they all implement the cost method in a different way, but as far as external viewers are concerned, they're all just things that respond to cost. From the outside, from the message sender's point of view, all of these objects are the same. And it's super important that on the sender side, you refuse to know anything special about any one of these objects. The goal here is to make the polymorphic objects be interchangeable from the message sender's point of view. And if there's something over on the message sending side where you say, well, I know something special about this one, and if it's that guy, I'll do this, the whole system breaks down. The way to break the dependencies here and remove that conditional on the sender side is for the sender to absolutely insist on being ignorant of specific implementation details of these polymorphic objects. As far as the sender is concerned, they're all the same, and they're completely interchangeable. Senders know what these collaborators do, but they absolutely refuse to know how they do it. And systems constructed like this, with this level of ignorance on the sender side, are extremely tolerant of change. For example, imagine that you were to create another new kind of shock. This star shock class is just like all the others from the message sender's point of view. They're completely interchangeable. It doesn't force any changes on the sender in order to collaborate with this new kind of shock. But again, this only works if message senders treat all the objects as interchangeable. They can't know anything special about one of them. If message senders are to be immune from the side effects of adding or removing new kinds of shocks, then they have to be ignorant of the differences between them. All they can know is about their public interface, and that interface has to be exactly the same for every one of these objects. So shock should be ignorant of the names of all these classes. It shouldn't know the implementation details inside these classes, and it shouldn't know how to pick which class is the right one for any certain circumstance. And I can see you wondering, well, okay, but someone has to know those things. Yep, someone does, and that brings us to factories. It's the responsibility of a factory to manufacture the correct instance of a role-playing object. The factory knows all those things that the shock class doesn't know. The factory knows all the names of the types, and it knows how to pick the right type for any specific circumstance. Since the factory is doing the choosing of the object, the factory is where the conditional goes. The factory contains the conditional that chooses the right object. You can think of factories as the place in your application where conditionals go to die. Isolating conditionals in factories loosens the coupling between the objects in your application, and it lowers the cost of change. So shock knows about or depends on the name of the factory, and the factory is the place that knows about all the names of these other classes and how to pick the right one. The factory picks the right object and returns it back to the shock class, and the shock class doesn't know what type it got back, but it does know that it got an object that plays the correct role back, and it has a conversation with it based on that API. If you arrange code this way, if you isolate the conditional in the factory and the names of the types in the factory, it means that it doesn't matter to the shock class, to the object that wants to interact with the player of the cost role. That class doesn't care if you add or remove new shock types. The changes that need to be made to add or remove an object all happen in the factory. And the factory contains a very simple bit of code. It doesn't have any of the actual behavior. It just knows the names of the objects that do. There's lots of different kinds of factories. They can be implemented in a number of different ways, but there's a set of common factory patterns that we're going to look at through the remainder of this chapter. No one style of factory is right for every case. It just depends on the problem at hand. It's important that you understand, though, a couple of different common variants of factories so you'll be able to choose the right one for whatever situation you're in. The factories that I mostly use vary along just a couple of dimensions. Either they're open or they're closed. That's one dimension. Either the factory owns the choosing logic or that logic has been dispersed back into the objects that are being chosen. That's the second dimension. And either the factory knows the names of all the types or the objects themselves tell the factory that they would like to be chosen. So those are three dimensions: open or closed, where the choosing logic lives, and who knows about what things should be asked, whether they want to have instances of themselves manufacturers. We're going to examine all those variants in the rest of this chapter. And now, given that high-level introduction to factories, let's move on to 7.3 and write the code to make this factory open for extension. So that's it for Fathoming Factories. That's just an overview of the idea of a factory, which is a key concept in OO. If you do real OO, you have objects that play roles, and then you need some way to pick the right object, and that's what factories are for. Now we're going to watch section 7.2. In it, we're going to make the factory open. So we're going to expand and just do one of those flavors of factories that I was talking about at the end of that prior section. For this, you're going to need to understand the code a little bit. So let me just run you through the code that's going to be used in the example that you're about to see. The purpose of this code is to produce the lyrics of the 99 bottles of beer/beverage of your choice song. It contains a bottles class. This class has, among other methods, a verse method. And as you can see, the verse method is responsible for producing the lyrics for a verse of the 99 bottles song. Inside this method, we call bottle number.for on the value of a number. And this is a factory. For is a factory method on bottle number. And its job is to convert a raw number into an instance of the correct bottle number class. If I scroll down, we're going to scroll past 4 for a minute. We'll come back to it. Notice that bottle number has all these methods. And bottle number is the generalization. Most numbers can be represented by an instance of bottle number. But if I scroll on down, you'll see that there's a bottle number 0, a bottle number 1, and a bottle number 6 class. They inherit from bottle number. They're specializations. There are all kinds of bottle numbers, but these specializations have their slight variants that happen in these unique cases. Now, if I scroll back up and we look at the factory in the bottle number class, this for method that's on the class side, this is the method where the conditional went to die. This knows the value of a number and the name of the class that goes with that number. This is how we pick. Right now, this factory is closed, and in this next section, we're going to alter the code to make it open. All right, with that, on to section 7.2, something like opening the factory. This is section 7.3, opening the factory. Here's the current factory. It's not open. You probably recall that we had to crack it open and add the 6 case to support bottle number 6. That's not so bad. It's not so bad. If it never changed again, you could probably just walk away. It's simple and straightforward. There's nothing wrong with this code. However, there are circumstances in which we would prefer that this factory be open. I'm going to show you the code to do that, and then I'll talk about all those circumstances and the pros and cons of them, and we'll decide whether or not the code I'm about to write is a good idea. You've likely noticed that the bottle number classes follow a naming convention. It's the string bottle number followed by the value of the number. Because there's a convention, we can easily create strings that match the class name, and then there's a way with a tiny bit of metaprogramming to convert those strings into the actual classes that we want. Here's how that code would look. I'm going to use a begin, rescue, end block. I can hear you already screaming about using exceptions for flow of control. There's going to be a bunch of stuff about the code I'm about to write that you don't like. Just hold on to all your concerns and complaints until I show it to you and we talk about it. And then I'll address, I think I know all the things that you're going to complain about, so I can address them all at the end. So begin, rescue, end. I'm going to use constget. I'll come back to that in a minute. And then I'm going to pass to constget the string that might represent a class name. If the number is 0, 1, or 6, this will really represent a class name. If the number is 37, it's obviously not going to. Let me stop right here before I write any more code and do a brief digression to explain this constget. And I'm going to have to do a circular route. We're first going to go to garbage collection. How does garbage collection work? You know, back in the old day, we used to have to allocate memory and deallocate memory, or any memory that you used got referenced forever. It never got garbage collected, and applications would get bigger and bigger and bigger because of memory leaks until eventually they blew up. That doesn't happen anymore with modern programming language. We have this thing called garbage collection. What the garbage collector does is it cleans up objects that you're not using anymore. How does it know that you're not using an object anymore? Well, the reference count, the number of times other objects point to that object, drops to 0. When the reference count of an object drops to 0, it becomes eligible for garbage collection, and the garbage collector goes and grabs the object, destroys it, and reclaims the memory that's being used. And that's why your applications don't just get bigger and bigger and bigger and bigger and bigger until you exceed the amount of memory on whatever machine you're on and have everything blow up. So that's the garbage collector. Point 1. Objects become eligible to get garbage collected when their reference count drops to 0. That brings us to a question you might not have considered. Why don't class definitions, get garbage collected? In Ruby, classes are just instances of some other class. Everything is an object. You could try this in IRB or Pry. If you ask something for its class, like if you ask the string A for its class, it'll tell you that its class is string. However, the class string is also an instance of some other class. And you can ask the class string for its class, and it will tell you it's an instance of, I'm really sorry, class. As confusing as that is, don't worry about that. You can go, if you're interested in this stuff, you should go look in the Ruby internals and enjoy that. The point I'm trying to make here is that all class definitions are actually just instances of objects. They're instances of some other class, the class. So why don't class definitions themselves get garbage collected? Well, now that you know something about garbage collection, you know that it has to be because they're referenced somewhere. And the place where class definitions are referenced are in what I think of as the big Ruby hash in the sky. So there's a place in Ruby where there's what is effectively a hash, where the keys are all the names of the constants and the values are all the values of those constants. And that hash is pointed to from the system roots. It gets built when Ruby boots up. And so its reference count never drops to 0. So because its reference count never drops to 0, it's never eligible for garbage collection. And because the class definitions are on that hash, they stay there forever, even if you're not creating instances of those classes. And that brings us back to constget. Constget is a method that you can pass a key, and you'll go look up that key in the hash in the sky and give you back the value. If the key you pass is a string that matches a class name, what you get back is the class. It says if you referenced the class by its name, you're holding on to a pointer to the actual class, and you can get an instance of that class that you got back. As yet another slight tangent before we get back to the point, this notion of classes never being garbage collected explains why you have to be really careful about putting data in class variables. It's not that you never want to do that, but you have to be careful. You have to really know what you're doing. Imagine that you have an array that's going to just keep getting bigger and bigger and bigger over time. You're always going to add things to it. If you were to create an instance of an object to hold on to that array, and eventually you quit using that object, the memory used by that array would get reclaimed. If instead you put that array on a class variable, even when you're done using it, it's never going to go away because the class is never going to get garbage collected. So be super careful. You might be in a situation where it seems convenient to throw some data on a class, but you really have to know what you're doing because that data is never going to go away unless you somehow clean it up yourself. All right, so back to this code. I've built this string that might represent a class name. We're passing it to constget, and if it can find a class by that name, I'll get back that object, and I can just make a new one. I can make an instance of it, but that's only going to work for bottle number 0, 1, or 6. All other values of number are going to raise an error and come back in the rescue block here. So I have to rescue something. What should it be? I'm already committing sins here by using begin rescue block in this place, so I'm not going to rescue exception here. That's too high up in the exception hierarchy. The error that gets thrown when you try to reference a class name that doesn't exist is name error. And so I'm going to be as precise as I can be and rescue name error here. If it throws the exception and I catch a name error and it comes back in the rescue block, the class that I want is the default class, which is just bottle number. So that's what I'll return here. Now that the whole begin rescue end block is done, I've selected a class. And of course, I need to create a new instance of it and pass the number into that instance. If I save this and run the test, I clearly don't have a syntax error. And since I don't have a syntax error, I can delete the old case statement factory and run the tests again. And sure enough, this code still works. So now we can lean back and think, is this better or worse than what I had? And it's definitely open now. You can create new kinds of classes and they'll just automatically get manufactured by this factory as long as you follow the naming convention. But there's lots not to like about this code, and let's talk about what those things might be. This new version is harder to understand than the original. The case statement is just as simple as it can be. It just writes it all down. And here we have this sort of inside-out metaprogramming where the default is in the rescue block. I mean, it's not obvious what this code does, and that might be an issue for people. It's a very valid, legitimate complaint that this code is harder to understand. Another problem, the class names that we're using are no longer actually referenced anywhere in the code. For example, there's no place in the code where the string bottle number 0 as a class name is written down. If you search for it or grep for it through your code, you cannot find a reference to that class. And that can make it really hard to figure out where things are getting used. When you start metaprogramming class names, how does anybody find them? Where do they get used in your code? An even worse case is that someone in an excess of cleanup zeal might notice the bottle number 0 class and look for it and decide it's not being used anywhere and delete it out of your code, which you're just going to have to hope you have test coverage for that. These metaprogram classes, a big downside is you can't find them anymore, and good luck looking around your application and trying to figure out who uses them. Problem number 3, the factory uses an exception for flow control. Now, this must be bad because if you search for that term on the internet, you'll get lots of people hating on that idea. And I understand, I don't disagree. They're right about that, but I don't really care. Like in this case, this feels like a reasonable use of an exception. And you could do this with a conditional if you wanted. You don't have to use a begin rescue end block here, but I find this convenient. It's so hidden away in the factory. It's not out in my sort of main programming logic where I'm doing all the businessy things of my app. It's inside, private to this factory. And so I'm just not very moved by that complaint. Every rule is meant to be broken, and I'm happy to break this one here. Another problem with this code is that it silently ignores classes that don't follow the convention. If you get some newbie in your shop and you tell them to go in that little bottle number hierarchy and create a new class and they make a bottle number SIX, it fails silently and they have no idea why. They can't understand this code when they look at it. They might not even know where this code is. So if the convention is not clear to people, there's no way to get any feedback that your entire class is correct. It just has the wrong name. There's no help anywhere in the system for doing that. So, given all these very legitimate objections, is it ever okay to use a solution like this in your code? Well, sure, because sometimes this is the most cost-effective thing for you to do. One thing that might happen is you might have lots and lots of classes coming and going, lots and lots of bottle number classes, new ones being created, old ones being destroyed. The day someone says, I am so sick of editing the case statement in this factory, probably is the day when you should be using a little metaprogramming to figure out what class names you should manufacture. It's also true that some systems are so dynamic that you as the programmer may not even know what the names of the classes you have are. I worked on a system once where we were getting, this is going to date me, we were getting like UML feeds that had information in them that we were using to dynamically create classes, but we knew something about, like they were changing the bodies of classes, but not the class names themselves. And so we had this list of classes that we expect, and we wrote down that list on our side of the wall, of the UML wall, and they promised us that they would never add or delete a class without telling us. And then, of course, they did. And we got tired of getting calls in the middle of the night that things were broken. And so not only did we dynamically create classes, but then we would dynamically build our list of the classes that we had based on what came over the wire. So there are systems of such dynamism that your only choice is to dynamically build class names. It doesn't make the other problems that we listed go away. You still can't find the classes. If you're looking for them, you don't know where they get used. Someone might delete one. The code is hard to understand. All those things are true, but it's just cheaper than the alternative. You know, for every question in OO, the answer is always, it depends. And here it depends. We're just trying to save money. We want to write the most cost-effective code. Sometimes adding a little complexity will reduce overall cost. You have to be careful because we want to be more overly complex a lot of times. But if complexity will save you money, then it's cheaper and you should do it. If this code is saving you money and somebody looks at it and complains that they don't understand it, tell them, don't look. Factories are for grown-ups. And you want to be the grown-up that gets to write them, which means you have to build some tolerance for these techniques and some understanding of when it's appropriate to apply them. So this completes a simple open factory and leads us to section 7.4, where we look at another factory where the class names don't follow a predictable convention. So that's it. I hope you enjoyed it. Hope you learned something. Hope you donated some money. Thanks for watching.
You did donate money, everybody, and
A lot.
we made it to 100 grand. Bam! Okay, I'm going away because this is Toby's show now. Bye.
Oh, well, instead you... Well, thank you all very so much that, Cassie said it multiple times yesterday, when we started this all, we thought wouldn't it be grand if we made like 15K? And now we're like, over 100K, and it's quite amazing. Sandy's talk, maybe first we've all talk about beer. Don't worry, it's alcohol free. And so that and, the celebration really warrants like a good old beer to celebrate. But yeah, thank you so much. Keep donating. Not sure what our next sort of like goal is, but we'll try to make more money. We went a bit over time because I talk a lot, but we have break time now. And so your break time now is 5 minutes. We'll be back here with the startup part. So we'll be back here at 20, which will be, I guess, 5, 20, 17, 20 in UTC. So see you back here in 5 minutes. Go take a break, get a cookie and whatnot. And then see you back here. And thank you so much. Keep donating, tell people. And, let's keep the ship rolling. hello, hello. Just vibing a bit, I know the break was short. I guarantee you the next break is going to be longer. It's going to be a 20-minute break, and this time, no impromptu Toby sessions. So hopefully we'll keep with the time. So again, in case you weren't here, thank you so much. We had one, okay, we were all really excited. I mean, of course, more money helps more. So, keep giving. But we'll continue on with the program. So now we're sort of like I call it sort of like the startup or building companies block. We'll first have a talk by Lolly, and then later we'll have a fireside chat that I did with Sasha and Andreas. But first, Lolly is up, and Lolly is a co-founder. No, wait. Lolly is a CEO and founder at Contender, or like of Contender. And the topic is very interesting. So it revolves about the question sort of like, what do we keep and what do we throw away when we're building up a startup? And she tells a wonderful, very, very interesting story about building Contender and about startups in general. It's hilarious, it's great, and I'm sure all of you will enjoy it. So, have a good time.
Hello, and welcome to Engineering for Startups. That's 4. My name is Lily. I'm the founder and CEO of Contenda. Contenda is a unified content repository that helps businesses resurface and repurpose technical content. This talk does not assume that you've ever worked for a startup or that you're familiar with a startup. I will provide all of that context and information. My goal is to answer one question. How do you decide what to keep and what to trash when building a startup? My friend Cassidy asked me the question the other day, and I thought it was super interesting, and I thought I'd answer it for all of you. She's referring specifically here to software, like the technical side. When you're building a startup and you're iterating through a lot of ideas, what do you keep? What do you trash? In order to understand why this question is pretty interesting to me, I think you gotta first know what the priorities of a startup are like. So there's something called a unicorn. If you've heard of it before, it loosely refers to the idea that your company is valued at $1 billion or more. You might have even heard a variation of this called a decacorn. That is $10 billion. In order to get to this mythical unicorn status, in the early stage, your goal is to find product market fit as fast as possible. That is sometimes abbreviated as PMF. And in order to get to PMF, you're supposed to build as many MVPs, minimal viable products, as you can. MVPs are made of minimal viable tests, sometimes abbreviated as MVT. In order to do this, it really is like, it's kind of like if somebody drew you a treasure map and there was like an X at the end and there's just like a dotted line and the map has no other context. It doesn't say like what city this is or like where you are. It just has like a little squiggly line and there's just an X at the end. Most startups don't even find product market fit. I think the statistic is like 90% of startups fail. So that means that they never found product market fit. Once you find product market fit, it's hard to fail because it refers to the concept that the market pulls the product out of you. You cannot build as fast as people are willing to buy. At least that's the concept. So for us, Contenda was founded in March 15th of 2021. And originally we were building analytics on top of Twitch. Twitch is like a streaming platform with a really heavy gaming focus, though these days I admit that they've really expanded outside of that genre. Back when my founding team and I were kids, we always played video games together. That was kind of always our thing. And as we got older and, we moved to different states, we still hung out over Discord, watching Twitch streams, playing games together. It was always the thing that brought us together. And so when we had an opportunity at a hackathon to build something, we thought, let's build like analytics for Twitch. That makes sense, right? So we started working with a streamer named Ludwig. Ludwig broke a Guinness World Record for most subscribers in a month. And we said, hey, we know that churn is really high for Twitch streamers. Let's build some kind of like retention analytics, like amplitude or segment essentially, but for Twitch streamers. Those are B2B analytics products. And this that went really well for Ludwig, which is great. Unfortunately, we could not find many Ludwigs in the world. He is, in fact, one of a kind. And there was not enough people in the market to justify what we were building. Or, in other words, we did not have product market fit. And in this case, this piece of software that we were building, if it doesn't have product market fit and your goal is to get product market fit, what pieces of this should you keep and what should you trash? So now it's a good time to show you how we actually try some of these concepts, these ideas around minimal viable products. So there's a term in the industry called Wizard of Oz. It refers to the fact that, as you know, in the Wizard of Oz, the wizard is just like behind a curtain. It's not real. So what you can do to test hypotheses is you can build like the curtain, essentially equivalent in Wizard of Oz. You can throw a landing page up and describe all the things that you want to build, that you think you're going to do, and collect sign-up forms as an example. And that can gauge basically how much do people want this. You can build a Figma prototype and get on a call with people and have them click through and see if they're really engaged, like they really want that thing. And then lastly, you can also just build like static web apps, which is somewhere between perhaps a landing page and a Figma in terms of functionality to imagination. And one of the early static web apps that the current version of Contenda used is at this link, casadoo.contenda.co. So I mentioned early on that Contenda is a unified content repository that helps businesses resurface and repurpose technical content. So for us, that means that one of the highest priority questions we had was, can a machine generate high quality content? That was the goal, right? If you're going to repurpose or create derivative content from existing content, it needs to be of high enough quality, especially if you're talking about technical content, because it needs to be right. That's hard, right? Just being right is hard enough. It needs to have the same kind of tone and voice as the original person. So can you actually mimic something close to that? That was one of the questions we had. So if you go to casadoo.contenda.co, it's still live. This is a static web app, which means that it compares the content that the machine generated to Cassidy's actual content, and it allows the user to just mark it as true false, and it's meant to be like a little game. It's a static web app because the content that's in there isn't being pulled from any data layer. It's actually just hard-coded into JavaScript arrays, and it just iterates through that array and displays a new paragraph every time you go through it. If you want to make it more dynamic, you can. So in that case, in casadoo.contenda.co, we could have very easily written like a call on Netlify functions, such as like a save function, for example. And that save function could store your score and record it into a database of some sort and allow us to do some kind of analytics on it. If that is necessary to prove your MVT, go for it. For us, that wasn't necessary. We passed this link into a Discord and we just talked to the community, and that was fine for us. We did not feel like we needed to do some kind of like higher scale thing. But something that's interesting is that this is essentially the onion layer to it as far as building software goes, where you can start with like bare bones and add complexity as you go. Hopefully, if that went well for you, so if you proved your MVTs, then eventually you get to a point where you're like, okay, I now need to build the thing. Like I need to actually get something usable, like an actual product in the hands of people, instead of just kind of like the Wizard of Oz type things that I have. So when you're doing that though, you're not home free. Even if you validate your MVTs, there's a chance that like, you know, when it all comes together, it's not going to be exactly what people want. Time has passed. There's a lot of factors here. So for us, we chose things that were going to allow us specifically to tear things away easily and add new things easily, which means that, for example, on our data layer, we use a non-relational document DB. We use DynamoDB specifically. And the reason why we do this is because we weren't sure what the relationship was going to look like between all of our different data entries. We weren't even sure what we were going to store in the long run. We just wanted to put something up as fast as possible. So if you go into some of our really, really early tables, and I will spare everybody the embarrassment of actually screenshotting this for you, you can see that in our early tables, the structure, or at least the attributes that are there, are completely different than what we have now. And there's some trade-offs to this. So in our code, oftentimes we will need to handle that retroactively. And what I mean by that is if we query that table, we'll have to do something like, if the attribute is none, meaning no parameter was stored for that because it came from a different time, don't do anything. Don't throw an error, because in DynamoDB and like in any database, if you try to query for something that doesn't exist, it will throw an error. So that's kind of one of the tradebacks. But on the other hand, it lets you build and add new things really quickly without having to worry about, did I mess up this relation? Is it going to block me from doing this invalid transaction, so to speak? And then there is the application logic. So we use serverless framework. Those are essentially, again, AWS Lambdas with API gateway in front of it. Netlify functions, essentially, when you have more than like a dozen of them, they can get really hard to manage. So we put everything behind serverless because it gave us this nice monitoring and logging layer. It allows us to deploy individual functions as well as the entire layer. It was really easy to spin up testing and dev, as well as obviously production. And then because everything was behind the same API gateway, it was relatively easy to tell the client, hey, call this new endpoint. We did not go as far as to use OpenAPI specifications. OpenAPI is really, really great if you know everything you need. If you know everything you need, you should totally use OpenAPI. Everyone knows the format, so it's going to be really easy for people to assume certain things about the pattern, about the inputs and stuff like that. We didn't do that because we didn't know what we needed. And so it was essentially going to be like way too much work to pre-plan all these possible endpoints that theoretically we might want to add in the future. But in the present, doesn't do anything for us. It doesn't add to our ability to find product market fit. So we simply did not do it. As you can tell by this concept, you're sacrificing a lot. You're trading off developer experience for product market fit. And I'm going to move myself in the middle here. It can be funny. So like on the left, for example, this was one of the very, very early versions. It's called Alpha 011 is, I think, the name of like the PR. So you can imagine if it's Alpha 011, that is super, super early. And this is one of our engineers, Johnson, essentially talking to himself. And you can even read this one comment, right? Who would just forgot to test their code? Johnson, that's a grammatical error. He means like, who would forget to test their code? And if you've ever worked for a large enough size company, and by large enough, I mean anywhere with over a dozen engineers, you probably have something called automated testing, or like a CI pipeline that checks all code before it gets merged in. And you definitely can't approve your own PRs. You definitely cannot do that. And here you can. And we've added some of those layers. These days, you can no longer merge your own PR without getting a second engineer to approve it. But we give everybody super push powers. So like if you need to force merge something in, you can still, and there's no check on that. It does now have to pass Circle CI. So there are some unit tests. Just the bare minimum though. Okay. So it's all good fun until we talk about the actual problems. So I mentioned early on that we were using document DB type things, so we just add new rows, add new entries, whatever. It's all good. There are times when we did just like make new tables. And one of the states that we converged to essentially was we had all these duplicate looking tables that had similar or overlapping attributes from other tables. And it got very confusing, essentially. Like, why does this one line query like 7 tables to put everything together? Why does this not exist in just one table? Another common one was like, wait, this endpoint has like a get call to it, but the equivalent version of this is a post. Like, why are you passing in parameters into this get request? So endpoints were not consistently named. They didn't have like a logical following of patterns. And the way I refer to this is essentially it depends on the era of which it came. So when we were building different versions of the product, we had different ideas of what that long run vision was going to look like. Like, what's this final thing going to look like? Who's it going to serve? What are they going to do on it? It varied. It varied from week to week, from month to month. So when you're making these like engineering decisions about what something's going to look like or how's it going to interact with something else, you consider that, right? Because you want to make your life easier. So you're thinking about that long run thing, and you made a decision based on the era of which the product was from. And it's kind of funny, kind of not, but here is our web app. The web app itself. So this is the front end. This has nothing to do with the back end. Yeah, I love this little like thing on the right where GitHub tells you the commit activity over time, because you can see where we abandoned it. You know, it's very clear when we abandoned that repo. And the decision of when to abandon the repo and when to like keep working on it, it's also kind of like, you know, it's eras. It's eras. We roughly call things like, you know, these is the 1980s, this is the 1990s, the 2000s, Gen Z, Gen X, Boomers, whatever. They're eras to Contenda. They're really clean cut too. When we start building one, we kill the other. It's actually gotten so bad, or perhaps so good, depending on how you look at life, that I spun up a joke website for April 1st. This is called contendees.com, and you can generate names for our repos using this thing. Truthfully, our repo names are actually much worse, because sometimes we sneak in like camel case versus Pascal case versus snake case. So you never know. In fact, one of the trivia questions we recently asked the office was to list as many repo names as you could correctly, including the spelling and the casing. And I believe the highest score was 6. We have 50 plus repos. So, it's bad, right? So like, you're going to fix it, right? You're going to fix this. Soon we might fix it. Soon, I hope to fix it. But also, maybe never. Maybe I never fix it. So Twitter is Twitter's a product company. Everybody knows Twitter. And this article came out in 2019, November. I think it's really funny. It's definitely written by somebody who's not an engineer. Sell Twitter stock because a tech debt is hurting the outlook. Twitter was founded, I believe, in 2006. So at this point, at this article, Twitter's over a decade old. And as you know, Twitter doesn't have a couple of like what people might consider basic functionality. For example, you cannot edit your tweets. Once it's out there, it's done. But Twitter is like a very, very large company with a lot of engineers. Like a lot of times this will happen every once in a while where it'll be like, how come Twitter can't just add an edit button? And I remember a tweet thread where an engineer actually explained why they couldn't. And essentially it boils down to like the backend's a total mess. And I can't just add something like that because it wasn't in the plans from 10 plus years ago. And so now we're here where tech debt is preventing me from adding new features. So look, it is technically going to reach a problem, right? You're going to hit a point where the decisions that you made many, many years ago to find product market fit come and bite you in the butt. You should probably view that as a blessing, actually, because most companies don't reach this point. And when you are the size of Twitter and you have all the money of Twitter and the engineering talent and things like that, you will figure it out. That's what you should tell yourself. You will figure it out when you get there, because most people will not get there. And I do have an interesting story about how Twitter structured their original data layer. So this is the early 2000 version of Twitter. It clearly looks very, very different from what Twitter is today. And one part I want to call out is actually just the header. It says what your friends are doing. This is really interesting. Twitter was originally built for friends, similar to Facebook. So, if you think about the number of people that you actually know that you might consider friends or like acquaintances, it's probably in the hundreds. I'm very doubtful that you can have like thousands and thousands of actual friends, but you probably know of a couple hundred people. So that was the early version of Twitter. In that version, a relational database schema makes perfect sense. These schemas, by the way, are courtesy of Designing Data Intensive Architecture, I believe it's called. The author is Martin. It's an O'Reilly book. I highly recommend it. So anyway, if you are talking about every individual having, let's say, give or take 500 followers and 500 followees, where it's you follow about the same amount because these are supposed to be friends, so people that you know directly, it makes sense to have it as a relational database. So let me move it around. But as Twitter grew, one of the things that became very abundantly clear is Twitter users are more likely to be lurkers than tweeters. So think about how often you send out a tweet and think about how often you scroll through your newsfeed. Chances are you're scrolling more often than you're posting. That actually kind of creates a problem in this relational database schema. It gets extremely expensive to fetch all of those reads. And so in 2012, it looks like Twitter came out with a different database schema for this kind of lurker economy, we'll call it the lurker economy. So in that scenario, it was it builds tweets for each user ID. And then it puts that tweet, the timeline, behind an API so that when you, the user, go and load your feed, it's one query and it's fast. That makes perfect sense if you are a lurker. But if you are, let's say, a celebrity with millions of followers, it's actually more efficient to be that relational database schema. So even today, Twitter does use both of these database schemas. It has something from the past, it has something that made sense in the present, and then it kind of has something that from the past now makes sense in the present, which is celebrities, which I don't know if Twitter necessarily expected to have celebrities on their platform like that. The thing is that the platform or the product will do things that you don't expect, and you can't know what people are going to do with your product. And as engineers, our job is to meet the business goals of the product, not to just, code this infinitely scalable thing that can serve, our imagined use cases, but it's to observe what actually happens and to meet that demand. So the answer for, are we ever going to fix it? Well, we're going to wait as long as we can. I mean, Twitter does eventually tackle a lot of this tech debt. I think actually recently they talked about how they spent the past year, I think in one of their shareholder announcements, that they spent the past year cleaning up stuff. So, if we ever get as big as Twitter, we'll have a cleanup day or a year. The other things I want to kind of keep in mind here is you should probably write code for a business purpose, at least at a startup. That's really the goal. And this is really more of a note to myself than it is to you. But I am probably overthinking the architecture. Just build something. Like just do it. And then, all right, so that's about it. This is us. Thank you for supporting Ukraine. Thank you so much for your donations. Thank you for remote.com for hosting and organizing this. It means a lot. I recently just hired my first senior engineer on Remote. He's based in Hungary. Remote made it super fast and snappy to hire him. It's the same as when I pay the rest of my employees on JustWorks, but now I get to have, the global talent at my fingertips. If you are a startup, if you work at a startup and you use like startup fintech things like Ramp and Mercury, there's a pretty good Remote deal where your first hire, Remote waives all their fees. And that's what we did. It was super awesome, super great. So check that out if you are a startup. And then if you want to find me, these are the places where you can yell at me. And this is my LinkedIn, my Twitter, my email, should you desire to. And yeah, come check us out at contenda.com. Thank you so much, everybody.
Well, thank you very much for the really, really great talk. I enjoyed it. That was really a great look behind the scenes, of the startup and how things go. And then even, looking at the bigger startups. So I might be overdoing it, but I think this just entered, my list of my favorite talks of all time. So thank you very much. And I'm not just saying that because Remote got a free ad in the end. So I can say hey, look, Marcelo here, free ad, we're doing good things, not only for Ukraine, but also for the company. But, this is mostly about Ukraine, not about us. So, and with that out of the way, we have, our next bit where we can get a look into, some really experienced people's minds when it comes to building applications, building companies, building startups as well. So I had a fireside chat with Andreas and Sasha, and I believe I introduced them in the fireside chat, so I won't steal your time anymore. But before we go there, after this talk, we'll have another break, and then we still have sort of like the Elixir and the open source sections of the conference, so also stay tuned. But for now, please go and enjoy this fireside chat with all of us and donate. Hello and welcome to this fireside chat at the Desk for Ukraine conference. With me, I have two really experienced programmers of whom we'll try to grab a little bit of the knowledge, extract it and distill it for you so that you can learn and we can share this. So with me, I have Andreas and Sasha. And Andreas, could you please quickly introduce yourself?
Yeah, sure. I have a very long, very confusing CV. The more short, more interesting version is I was CTO and founding team at Product Hunt. We sold to AngelList. At AngelList, I led like engineering teams in the crypto team, which is called CoinList, and also worked on product engineering in the talent team, which is like the job sites of AngelList, if you know them. Nowadays, I'm CTO at OnDeck, which is like an online accelerator for careers. And on the side, I invest a little bit in startups.
Like remote.com, if I'm not mistaken.
Yeah, I'm actually wondering, is this one of those cases where the sponsor gets like a panel seat? Although they have nothing to say.
You have a little seat. And Sasha, tell us about you.
Hi. So long story short, I've been developing software for the past 20 years. And in the past 10 years or so, my focus has been on the Beam platform. So mainly Elixir programming language and also earlier a little bit of Erlang. And these days I'm focusing more on helping teams work with Elixir, use it in production and adopting this technology.
Cool, thank you. Yeah, that was one of the first things that jumped out to me when I sort of like looked at the two CVs before we got here, and I was like, oh, wow. Like the first entry for both of them starts in the year 2001. And when I sort of like wrote that back, like I think I was in maybe 7th grade or something. And I'm also, not the youngest anymore. When I've also been working for like 8 years and I'm a staff engineer. So, while I think I have some experience, both of you have, a lot more experience than I do. And like, 20 years is a long time and there's a lot to learn in that time. And that's sort of what we want to talk about today. And so the first thing that I want to throw in the room basically is sort of like you get a call from someone to start a new company, get on a new project, and it's a complete greenfield project that you want to set up. What are the things that you try to watch out for? What are the things that you try to do right because you've seen them go wrong and now this time you want to do them right?
Sasha, you want to go first?
I wanted to actually let you go first because of your more management focus.
Damn it. First Tobias calling me old and now this.
I'm sorry.
I mean, a part of the fact that you should really double check when you like join a team that very early, if they know what they're doing, what the founding team is, what they're building, all this kind of stuff, like do your homework. When it actually comes to the main implementation, pick a stack that you understand really well. Early on, it's mainly about figuring out if the thing you build actually makes sense. So iteration speed is like the most important factor here. And the second one I would always advise is when you build out stuff, when you like build code that you sooner or later has to be under management, build in a way that's easy to delete, because sooner or later you will have to delete it.
Cool, but I have a follow-up there. What do you mean? So like do your homework, do your due diligence on the team? What do you mean?
This is like true for any job. Like when you join a company, you need to double check if this is worth your time, worth your life. Like it's a part of your life, even if it's only a few years. Like this will be a part of your life. It will define a lot of like your happiness and your future. So basically do the homework, double check if this is worth your time, and if it's like a very early stage company, and you are planning to stay a little bit longer on that, like if it's a freelance project, obviously a different discussion. But if you plan to join like as an actual like long-term commitment. Make sure that the team has same values as you, understands what you're thinking about, like understands what they understand the market, understand the product, and so on, so that you can actually excel at your part because they excel at their part.
Cool, thank you. Sasha, what do you think?
Yeah, I think this is a great advice. I was once in a situation when I was joining like very early phase startup and very early phase project, and basically, I wanted to myself make sure that that the idea makes sense and the whole this product is not something that I just don't agree or don't see the point at, and that the team seems nice, and someone I can work with. And otherwise, I would say, speaking about values, to me, this is perhaps the most important thing about starting a new venture, as a team effort, right? So I think it's essential to distinguish between we are just a bunch of people thrown together versus we actually try to work as a team, right? And so to me, I think it makes it's the most important to somehow establish a core set of shared values, And I know that it sounds like sort of motto for some marketing and whatnot, but it's really, I think, if you want to work as a team, we need to have some shared set of values, because otherwise it's just not gonna play out very, very nice. So I think that we should figure out, like, we definitely, of course, want to provide business value, but I also think it's important to organize the code, just as a note for the viewers. I'm going to speak mostly from the developer's perspective today. So we want to organize our codes in a way that we can keep on providing business value down the road, right? Because it's not like we are going to be done in 1 month or 2 months, it's a perpetual activity. And, otherwise be nice to each other, help each other, basically understand that we are all in the same boat, and basically we are as good as everyone on the team. So we basically need to lift our teammates up if they are falling behind for whatever reasons, or if they cannot be productive for whatever reasons, and vice versa, right? So this will be, to me, the most important thing about starting the new venture. Technology, what Andreas said, something that you're comfortable with, something that can help you with a quick start, because if you're when you're starting, you're exploring the business area, you're really not completely certain what you want to build. And if at the same time you also have to explore like a completely new technology, then it's going to be like double the challenge, or even more, maybe even more complex than that. So even as an Elixir sort of self-appointed evangelist, I sometimes advise to people, like, you don't really maybe need Elixir, at least not at this point, if you're not really comfortable with it, like why did you pick that thing,
Yeah, thank you. And so I love that, we started talking about values and the team first, and sort of like code second, and like the alignment between the team. And it's really interesting. I remember I once interviewed for like a very early stage CTO job, and was sitting there in an interview with sort of the co-founders. And then I was like, okay, sort of like, what are your values? How do you work together? And they sort of like looked at each other and tried to sort of like make it up as they go. And they had been working together for half a year. And I was like, oh, they were like, oh, that was really good. Maybe we should do a workshop about this. And I was like, yeah, maybe you should, if I joined, we should really talk about this and see what's happening. But at the same time, I often feel sort of like values are one of those things that are easily said, but it's very, very hard to do right. Like I've been in places and I've seen places where, the values were a poster on the wall, but like nobody actually lived those values. They would maybe point at the values to just get their thing through. So they would weaponize the values to get what they want, but they wouldn't actually live by the values most of the time. So anyone have any sort of like
values?
How do you have these values and keep them?
Values is what people do, not what people say, So like all these workshops and these lists of values quite frequently are just bullshit.
Yeah.
A company in the end is people trying to make decisions together, and the better decisions they make, the more successful the company will be. And if you notice that they're already doing like weird decisions early on, like micro decisions that are weird, like interactions and this kind of stuff, you can assume that this will like extrapolate into the future as well. And this is usually the area where you actually notice the real values, So like, for example, like directly asking them for values might be hard, unless they did a workshop, and then it's most likely bullshit. So like rather look at how they interact with you, how they interact with people who are not like you, and all this kind of stuff.
Yeah, I would say that values is maybe a synonym for culture, right?
Culture,
So, culture spreads kind of like a virus. You know, I'm not going to say COVID because it's still too well. I said it obviously,
Too soon, yeah.
Yeah, cut this part out. So, what I want to say is like, let's say that the three of us are in a team, for example, right? And we are just, developers. We are coding, and so I maybe am a bad agent or bad member. So I just, hack and whack, push directly to the main branch without consulting, rewrite your type of code into my type of code and so on. And ultimately everyone's going to start doing it, right? On the other hand, if I try to play nicer, maybe make some pull requests, ask for review, discuss with you in a more open-minded way, right, where I accept criticism and accept proposals and different kind of ideas, then that's going to spread, And so basically, I think that like when the team is very small, you establish some values and then you just sort of share those values, not by some workshops and whatnot, but simply by behaving the way we behave. And I think that the Elixir community is a nice example of that. So those of us who has been early around, remember how Jose was always very nice, very constructive. And, even when someone would be more aggressive, he would always, respond nicely with arguments and I think that this kind of attitude sort of spread wider in the community as the time went on. So I would say that this is a good example of how it just, it spread simply by doing it, by practicing it, right? Rather than by preaching, you should do this and this and this.
Yeah, it's always lead by example, that's always, I don't know, I always have the highest expectation for myself. So like, I'm very punctual, so very typical German. So like when I'm a minute late for a meeting, I'm like, no, I'm sacrificing all my values. Now nobody needs to be on time anymore because I'm late. So I always stress about that quite a lot more than I should. So yeah, that's okay. That's cool. So we talked about the values, and we said technology doesn't really, matters, but doesn't matter that much. Take something that iterate and find out what sort of the business is, what the domain is, and use what you're comfortable with. But looking at that, we all have sort of like, let's say, a favorite piece of technology that maybe, when we start a project, if we say like, okay, I'll bring this with me because this has served me very, very well in the past. And I just wondered if, is that just me? Do you have like that piece of technology that you would bring into almost any new project? And if so, what would it be? And, why would it be that kind of technology?
Sasha, what do you have?
Well, for me, unsurprisingly, when we talk about technology in particular, then it would be, of course, Elixir, right? So it's, I tried different things. Well, I not tried, I used different things in the past. My early starts were with C++, then C#, then Ruby, lots of JavaScript at some point, and Erlang, and then Elixir. This is where I settled for the past 10 years. And I'm hoping I won't have to change that, at least for the time being, given what's currently in the offering. Meaning no disrespect to other technologies, of course, but this is really that somehow hits the right chords for me. But having said that, again, technology, I'm not going to say it's unimportant. It's very important, right? This is what we use to build software, but realistically, you can do things in other technologies as well, and people have been doing it. But either way, just to explain briefly, roughly speaking, I had this talk which demonstrates in more details called Soul of Erlang and Elixir. So the core of it is the Beam platform, the virtual machine designed for Erlang back in the day, which really supports well writing fault-tolerant and scalable systems, but it works well even if you don't really need to work on a super scale. And then Elixir is kind of like sort of like an icing on the cake. I feel that I may be not giving it enough credit, but it basically gives us tools, or the philosophy it uses is very developer-oriented, developer-friendly, so we can actually start pretty quickly, be productive very early on, and still, if we need to scale or if we need to write complex software, it's the language allows us, and of course the underlying runtime allows us that. So I think that it's a really nice combination between starting quickly, starting simple, but at the same time being able to go very far and implement very complex pieces of software.
Cool, thank you. Andreas, anything came to mind?
I cannot think of anything that I have not used in some other project. You know what I mean, I assume we don't count Git, for example.
We can count Git, you know.
That feels like cheating. I mean, I'm very strongly opinionated about a lot of stuff. You know, like if I have to have an API to the front end, it will be GraphQL and this kind of like things that I just strongly believe in. But I also did the exact opposite. You know, it like really depends on the project and like what you already have in the setup. Like if it's a fresh project, you know, it really depends. Yeah. In the end, it doesn't matter. That's like my take. Like whatever you're comfortable. Like it's kind of my take here.
Yeah, technology is kind of difficult to transfer, right? You come to a different company and maybe they use a completely different stack, and you know, it's questionable whether it makes sense to even use a completely different technology and whether that's going to be met with some enthusiasm. So yeah, I remember when I, after some 5 years of working with C#, went to a different company that was just using Ruby, and yeah, that pretty much made no sense. So I had to learn a different kind of language, right? But you know, one thing that I try to transfer, you know, ever since I started doing it is it's not a technology, but rather a philosophy of working, of organizing the commit history well, and working in small increments, in small pull requests, if you will, like if there are code reviews. So, you know, rather than, you know, giving you this large pull request with a single commit, I'm trying to always focus it, you know, reduce the scope as much as possible so people can grasp it and then they can produce quality reviews. And increasingly, I'm working proactively to make the history clean, you know. So if I like go a little bit forward and I see like, okay, this history is a mess, you know, I'm at the right place where I want to be code-wise, but the history is not good, then I'm gonna just return and rewind in a more understandable way for the reader, for the reviewers, right, to make their job easier. And I think that this is actually, not to make myself look perfect, this actually aids, helps reviewers, you know, do the better job faster. And of course, I want the better job, I want to have better reviews. And so these days, my progress is more like, you know, instead of just typing code frantically until I get something working, it's more like, you know, 2 steps forwards, 1 step back, and then, you know, deliberately doing this so I can help other people on the team assess the quality of that work better, right?
The few technologies that I will introduce in any project very instantly is everything that makes asynchronous work, you know. I call it like single player mode. Like this Super Mario would be really boring if you press jump and then you have to wait for somebody, you know what I mean? So like anything you can do for single player optimization is like useful. Big fan of like linters, like as many as possible almost. Like it honestly doesn't matter which style, it doesn't matter which best practice, as long as the company sticks to it, you know. And as long as like somebody who's working instantly sees what they're doing right or wrong. I'm always the first person to very aggressively take notes in meetings and like on very clear, like what is a decision, what is just like a suggestion, so that everybody else who afterwards comes can like get enough context without watching a 30-40 minute video, you know. Being very clear, short communication in general, like anything that makes asynchronous communication work, asynchronous working styles work in code or in Teams is like, from my point of view, the #1 thing I would always like introduce.
Yeah, the point about linters is really nice. The thing I like about this is that instead of, you know, I recall in my early days of career, there will be a style guide document, like 40 pages of rules, which no one would really remember. And you just cannot really grasp that stuff. And you have like this automated tool that tells you, you know, right, wrong. And okay, you know, you don't have to think about it. It's not necessarily always perfect, but at least it really just takes a lot of mental burden, you know.
Yeah, I mean, linters, CI, there were so many things that, you know, like many years back were not normal, and today, you know, they're just super normal. They help us a lot. And I think, you know, what both of you were talking about was like removing blockers. You know, I don't want to be blocked, you know. And also, I mean, even like working in small increments is always good. And that also means that, you know, because less changes are coupled together. That's the biggest thing that I hate about big pull requests, is that, you know, you do these other drive-by changes. Now all of a sudden, like either all of these 4 changes land or none of them lands, right? And so that keeps all of the other improvements back. And so, you know, you increase cycle time, you need to deal with all of the merge conflicts and everything. So it's, It's pretty bad. But I'm quite surprised because, I mean, maybe that's my bias. My personal favorite technology, PostgreSQL. A Postgres, is just solid. It can just do anything and everything. You want to do some NoSQL storage,
100%.
sure. JSONB, full text search, like indexing, it scales very, very well to like a very high degree. And like, there's all these features that work very solidly well. And so for me, it's always, no matter what programming language, whatever I do, I take my Postgres with me, and that is knowledge that will always help me. It will always be there for me.
Fully agree. Like we did in Postgres, you can also like have extensions to run V8, like Node.js code essentially. And we did this quite a bit actually in Product Hunt to have like very cheap workarounds and like not like implement a lot of complex infrastructure, just like let a database handle it kind of situations. Yeah, I mean, Postgres is like a no-brainer to me personally, but I also worked on very large apps that used MySQL,
It's a very versatile database, definitely. Yeah.
I mean, Shopify is running on MySQL, and I think Facebook is also running on MySQL. So it's like not a dig against it, but Postgres is just, I know. I mean, I don't want to, I want to throw shades. I think
it's kind of, going back to what I said, it's kind of hard for example, for me personally to say like, Postgres is the best because I really honestly only used Microsoft SQL Server, which I also enjoyed, back when I was in the more on Microsoft focused world in the first half of my career or even less than that. And, it worked well. We didn't really write super big apps, so I cannot confirm about anything else, but it worked well. I never really used seriously other databases like MySQL or Oracle and whatnot. So I have no idea, but people are again using those things to build large systems. So beyond doubt, they are working, right? That's demonstrable. So just like with Elixir, I have the urge, to always say that Elixir is to me really the best, or at least it hits the sweet spot for anything backend side. I honestly think that it hits just the right notes. But I understand if people are writing it in other technologies as well. Even though I personally would like to avoid this in the future as much as possible.
Wonderful. So speaking of things, to avoid, hopefully you have some stories up, but like one of the things that I feel like we don't talk about enough is failure. Like we all give these great conference talks and we're like, oh, this worked great. This is the best thing ever. And everybody goes like, yay, best thing ever. But there are way too few talks where we talk about, like I did this thing, it absolutely did not work. It was horrific. We needed to roll everything back. I did this huge mistake. And I think usually we can learn even better sort of from mistakes than from success, because we made a mistake and now we realize the mistake and it's like, next time I encounter the situation, we should do this differently. So can any of the two of you, like hopefully both, share a story of sort of like a failure, a mistake that, you made or the company made, and sort of what you took away from it and what would you do differently the next time it comes around?
Yeah, I have a list longer than our meeting. Number one is the classic one is over-engineering, over-design. Like that happened more than once to me. My biggest learning here is if you isolate well and you worry more about the interfaces between those isolations, like the components or whatever you want to think of them, that matters much more than the code in those isolations, So if those like pass the linter and they do their job and they have some basic tests like done, it matters much more that you have like a good isolation that makes it easy to delete and like the iteration speed. So like over design is like I ruined more than one company through over design, I think. The other one is this is like now maybe a contradiction, I don't know. It's not making like big enough product bets sometimes, so that you end up iterating on small changes that actually don't move the needle, instead of actually tackling something that potentially, like obviously you need to be careful and test and experiment. That's something that completely opens up a new area for the business, That's something that we did like a little bit like too much product minded, too engineering minded POV on stuff. And my biggest learning here is very frequently, sometimes you just need to find, or I think a good analog is here. You can take the same technology, sell it and struggle, and then slightly spin it for a different product positioning. And it's exactly the same thing. It's just slightly spun, slightly sold to a different customer, and all of a sudden it works like magic, you know? So sometimes you need to make these repositionings or maybe even bets on pivots and all this kind of stuff. And frequently the iteration speed you have for that, it like matters more than anything else that you do.
Cool, thank you. Sasha?
Yeah, well, I had a privilege of working on a couple of failed projects. Yeah, in retrospect, you know, it's kind of nice to have that experience too. And I would say that in all those cases, I think my impression is that the root of all problems was the lack of focus, what I would call. And so there are like two sides to the story. The one, from what I see as a developer, that happened on what I'm going to vaguely call product people. So those are people who are kind of driving the features, the product development. There was like a lot of we have to do this and this and this and this and this, and just, you know, just a bunch of features being thrown in, and it all has to be done like yesterday. It's everything was super yes, and a lot of, you know, of kind of steering, like let's go left, let's go right. And of course, I understand that you cannot really know upfront what you want. You have kind of a vague idea and you're searching for it. But that's one thing, and a completely different thing is if you're just, you know, very, very frantically, very frequently changing, completely changing your direction. And like one day you're going one direction, the other then another, then third day you return again back. And so that was very, very frustrating and hard to keep up. And perhaps the worst thing was that what I've seen in a couple of projects which failed was that there was actually a lack of concrete statements, you know. So like people would say, we want something very, very fluffy, but we want this yesterday. Of course, it's always yesterday, right? And here I kind of entered the developer story where I think one major problem of development was that we didn't really have a good attitude. We didn't just do a sort of pushback, like, okay, hang on a second, we can't really deliver what you want because we don't even understand what you're asking from us. Instead of that, we would just, you know, go to the keyboard and type frantically, over design, definitely what Andreas mentioned, so we can cover our bases, because we knew that you know, we're going to have to change direction. So we tried to prepare for that upfront. This was a colossal mistake. You know, I like to say, drawing from this experience, it would be more profitable, more, you know, efficient for everyone if we just didn't do anything. If we just, you know, stared at the wall or surf the net, you know, read the portals and whatnot. That would be better than what we actually did, because once we would get something concrete, then it was so different from what we built that the existing work was actually, you know, getting in the way of what we were supposed to be doing. So there's definitely that. And then I would say developer really have a different kind of sin. Again, lack of focus, in the sense that we tend to get very fascinated by shiny technologies, you know, new tools and whatnot. I call this like hacker news driven development, you know, and so that's one thing. And then if we do pay some attention to the design of code, we also tend to over design. You know, we go like full-blown DDD to implement a simple to-do list or something like that. And ultimately that design, that code architecture doesn't serve its purpose. You know, it actually also goes in the way of keeping that progress. So yeah, I would say that this is kind of in those couple of failures, this would be the root causes, in my opinion.
Yeah, I want to tack on to the focus part, because one story that really stuck to me that happened was I was working at a same-day delivery company, and we were implementing a new feature so that people could actually reschedule their shipment. So they would be like, oh, I'm not home today, you know, send it to me in 3 days or something. And we built almost the entire feature, you know, it was almost ready to release, until we realized that we're not sending an email out early enough for people to do that, because the first time we used to send the email out was when it was already dispatched to a tool. So at that point, it would already be sorted and picked. And so nobody ever sat down and looked at the entire process, it's like, from all perspectives, customers, the hub, our partners and everything, and went through the entire thing. And that's something that I think is often missing, because, I said, we want to build everything so fast, like, okay, build this. And that's, where I think great product managers come in and really pull you back and say like, hey, let's settle down, let's think through the whole process. Let's actually see like what is available at what time and do that. And here I got to do a quick shout out to my PM, Simona, who is currently on parental leave, because he did the same thing with me last time when we had a big problem. It was like, no, Toby, don't change this yet. And then we actually look at the process, and the change had to happen somewhere completely differently. And that way, you can really, as you said, sometimes the best code you can write is no code, or just sit around and wait until you really figure out what the problem is and you start building it. So I really, really want to emphasize that.
At the risk of sounding like an old man yelling at the cloud, I feel that like a big issue of our industry, and perhaps even the humanity in general, is that we're just obsessed about quantity and speed way too much than other kind of things, like thinking things through. Maybe it feels like sort of a lost art.
It's also like sometimes cheap when people think of like engineering teams as the people who have to implement what has been decided kind of positioning, which doesn't really work in early stage companies. Like in early stage companies, from my point of view, it's always like one product engineering team, and it's kind of the job of like everybody in there to figure out what to build, and in many cases, this kind of like left, right in the engineering team that happens for like product decisions is stuff that shouldn't even hit the engineering work already. It should be like maybe like experimented, maybe like landing pages, maybe there can be something built with like some basic no-code tools just to figure out if this path is actually the right one. And in many cases, like some of the best engineers I worked with actually helped doing that, or like pushed back and then like, hey, can we just like do like a quick experiment to see if there's a value in here? Meanwhile, those people will clean out something else up, and like you got like one more week to figure out if this is the right thing to do, some engineers I know even like just help others then to. So for example, at OnLake, we built like a lot of stuff also with no code. So with like Zapier and Airtable, because a lot of the web development business processes are essentially some random UI, something stored into a database, some side effect, and then like somebody editing stuff in a database and changing a state. And that's basically like a front-end Airtable Zapier. And as long as this product isn't like core mission critical, I don't want any engineer of mine to even touch this. When they hit product market fit, okay, let's talk, let's rebuild, like let's scaling. But until then, like do it yourself, like have fun, don't come here, figure out what you want, and then we can talk kind of situation.
Cool. So I think we're at time, but there's this one question I would really still like to ask both of you, so I will just do it, which is the classical question now: how do you keep the balance between like having a good and healthy code base and shipping fast? Because at times both of them can be at odds with each other. So how do you approach that problem?
Okay, maybe I'm gonna start now. So yeah, there is a great article by Martin Fowler. I think it's called "Is Quality Worth the Cost?" or something like that. I can try to find it later and send for some doc notes. And the quality here means really the quality of the code in the context of the article. And basically, Martin argues that this is a false trade-off. Essentially, he argues that quality makes us faster, or makes the development cheaper, if you will, right? So I think that in general, going back to the start of this discussion, to me, one value about the code is really that this is a shared environment. This is the working environment for the developers. So this is where, as a developer, I spend most of my time in. And I have to, a lot of time I have to figure out the code that I didn't write myself. This happens in a team effort. Very frequently, I get a job at a company where the code base has been for some time. So a lot of that code has not been written by myself, and I wasn't there, and I need to figure something out about that. And I want this to be efficient. I want this code to communicate with me, because otherwise it's very mentally draining, energy draining, and it affects my mental health. I've been working in some terrible code bases, some of which I even wrote myself, unfortunately. And it's taken a mental toll, and it's affecting our ability to progress, which is really, really frustrating. And ultimately, we cannot deliver business value. So to me, this is really investing in code quality properly with the focus, actually means delivering business value more efficiently. Of course, occasionally from time to time, as an exception, not a rule, we do have to cut some corners, right? So maybe there is an important business deadline that we need to meet, or maybe there is a critical bug, and I'm not just going to deliberate what's the best architectural approach to fix the bug. I'm going to fix the bug, ship the fix, and then maybe post-fact, clean up that code, right? So we have to be aware of those things, and as long as that's exception, I think that's perfectly fine. But if exception becomes a rule, then by definition, it's not an exception anymore. And unfortunately, very frequently, I've seen situations where, people say like, oh, we're just gonna, develop very fast, rapidly for like the next 6 months or so, and then we're gonna spend 2 weeks refactoring. That it doesn't really work like that. That's basically, the technical. Yeah, the technical debt metaphor, and I think the technical debt really is more like you're taking a debt at the loan shark, not at the real bank. So, those interests are just going very rapidly high up. So if you do even a month of rapid coding, you're going to need, I would say, maybe at least a month, if not more, to clean that stuff up, because it builds up very quickly.
Yeah, I think the correct answer is it depends.
Always the correct answer.
And we're done for today. So I agree with the fact that quality creates speed, or differently put, momentum creates, you don't look for speed, you look for momentum, and quality allows compounding. You build on top of stuff, and therefore you create more and more momentum, and therefore you have ultimately a lot of more speed, So I completely agree with that. The one problem you have is typically when you're building a new product, and unless you just copy something, but then you have a business risk. But if you're building a new product, you're usually kind of this early on, trying to figure out exactly what you do, and then over time it stabilizes and becomes more and more stable. The hardest thing early on is that you most likely are going to remove 50% of the code that you've written, and at some point rewrite 50% of the code that you've written because of scaling, nuance, additional, basically one half won't work and the other half will work, and therefore force you to change it, and you don't know which is which, and in both cases you're going to touch it again. And so this is why I come down to usually linters, automation, automated tests, just to make it easy to just build something okay, in a state that's easy to understand what's going on. Leave enough comments that people understood why you did certain shortcuts. Don't explain the code, but why you had to do the code like this. And a few other things like this, and focus mainly, this is again what I said a few times, make it easy to delete, because if it's easy to delete and you need to refactor it, and somebody like Sasha comes in and they're holy shit, we need to fix this, you know what, I can just remove it and then rebuild it, and that's most likely even easier than nuance changes, So yeah, again, it depends. Later on, or in general, automated tests, linting, good isolation, and in general, quality is the thing that creates momentum.
I would perhaps say that in those early days, what we're building, at least in the cases that I've seen, is more of a prototype rather than the actual product, right? So we're not really certain what we want. We do want to have some demos for the people to see, and also to get some feedback. I had this situation at one company, well, actually at multiple projects when I think about it. And so, yeah, you definitely want to get some tangible to other people to see, and then get some feedback. And really, you can just, change directions very quickly, but that's the prototyping phase, right? Mm-hmm. And so I would say once we get more to the stable phase, we definitely want to salvage some ideas from the prototype. But one mistake that I've seen often is that prototype becomes the project itself, and that's kind of I have some reservations about that. People are practicing this a lot.
Yeah. I will go as far as saying it's almost in every successful code base I've seen. Unfortunately, because they were really strict about quality, and then at some random moment, a weird side idea got product market fit, you know, and then they just like try to keep it alive forever, you know. It's almost like I will go as far as saying it's almost like the default, you know. There's like a saying that's super unpopular, but it's basically there's two kinds of code bases, the one that goes successful and the other ones that are beautiful. Yeah, again, linters help a lot.
Also tests.
This is like the one thing that that's always like fascinating to me when people save time on automated testing.
Oh, God.
I'm not thinking of like you have to do DDD or perfect unit test. I'm like just like please introduce very good like vertical cutting tests, integration tests or whatever that test the happy and the sad flow of the customer, so that you just know that the thing is actually working. You know what I mean? And like have plenty of those until they get too slow. And I'm always fascinated when people like quote unquote save time on those and then afterwards are scared to change stuff, you know?
Yeah, definitely. This has been my philosophy. There was a great talk about it called, I think, TDD, What Went Wrong. And a lot of this focuses on higher level, behavior level tests, you know. So the author, Ian Cooper, or the speaker, sorry, Ian Cooper says like test behavior, not implementation level details, right? And behavior means from the business value perspective. And this is what I want to do. I have been doing this in particular for the past few years and practicing with teams I've helped. And we had such great experiences with it, you know, especially, you know, my part of job was doing some post-factory refactoring for those teams to, you know, show them different way of building things. And with good tests, I had so much confidence. We rarely broke anything because tests were really focused on the observable behavior of the system, which is what you want to test. You know, meaning no disrespect to lower level or isolation level tests, you know, those have their value too. But what you said, basically behavior first, a lot of that, and then you can change the guts of your software, of your code, and be confident that it still works.
100%.
Yeah, without tests, I can't sleep. Wonderful. So, linters, tests, and values. You know, if I would to take, you know, a few words, maybe that's not the right few words, and we can find a better summary. But that's it. We are sort of like at time. I want to thank you both for taking the time to, you know, talk to me, talk with us, you know, at this wonderful conference, Death for Ukraine. Any last remarks that you want to make before we call it a day?
Well, thank you for the invitation. You know, it's been an honor. Thanks everyone for joining and for donating. And well, hopefully, you know, we'll see each other live at some point. You know, the things, at least COVID-wise, are looking better. So I'm hoping that the live conferences are going to start again soon.
Yeah. Nothing much to say. Like Slava Ukraini.
Thank you both very much. And yeah, please donate. And we'll see you at the next talk. Well, I hope you all enjoyed that. Although, you know, I made it a bit longer than I was supposed to, but I genuinely was very excited to get to talk to both Sasha and Andreas about all of these topics. And yeah, I hope you could take some good stuff away from it. And maybe that motivates you to be like, oh, wow, I learned so much stuff that is worth $50 at least. And so you can go to Death for Ukraine, and go donate. So, you know, we smashed the 100K, which is, you know, it's great, was our goal and everything. And I'm very happy that we did. But, you know, we still can do more. And, oh, yes, you know, the offer change is like, it's a superpower. You know, I just go underneath the desk, you know, bam, and then go up. And then everything is different again. And yeah, it's a trick you learn when you're around long enough. Anyhow, you deserve a break now, and like an actual break, not just a 5-minute break that I made you take before. So you'll have even more than 20 minutes. So that will be, I think, 1850 UTC, and so that's 2050 my time, Berlin, and that's 2150 Kiev, or like Ukrainian time. And I'm too tired to do the math. I think on Pacific time, which is why we have this so early, so that the people from San Francisco can join, it will be, let me look at my schedule, 11:50. So see you back here in a bit more than 20 minutes. And then we'll have the Alexia block of the day with 2 wonderful talks. Then we'll have another break, and then we'll have the open source part, and the Q&A with Joseph William is in the open source part. So even a bit more Elixir for reasons because we love Elixir. But yes, thank you all. Have a great break. Get some cookies, chill, relax, and see you back here later. Thank you. Well, hello there. We had a common community request by one Peter Solnicha to see the bunnies, which, sadly right now there's only one because Ghost is at the vet, but that's a sad story, so I'm not going to tell it. So you can see L caring for himself. And yes, my room is the bunny room. This is where I work. This is where all the expensive tech is. But most importantly, it's where L is, and usually a ghost. How is it living with bunnies? Well, it's quite fun. They're the cutest little things. I would hope that I could show you L eating. He has like healthy green snacks prepared over here. But he's more grooming himself. He is a little groomer. He likes to be very clean and very good. And if you're asking, is Toby always this weird? The resounding answer is yes. Toby is always this weird. Just the kind of guy to put on a suit on a whim because he thinks it's cool and he wants to support something and he loves all animals. Okay. I have to kneel down very weirdly this whole time to, bring you this picture. So we'll go up again. I hope Sonic saw this. If not, I'm gonna send him a clip of it. Well, hello there. We're almost on time. If you missed the bunny, then you missed out very, very much. And yes, I bought the ring light just for this conference because it is late in Berlin. It is very dark outside, so that you can see part of me, at least a little bit. I bought a ring light. Actually, I even bought this shirt and this tie today and this handkerchief so that I can pull out, so that I can do this outfit. All just for you and for Ukraine. So if you want to reward me for my full engagement with this and the effort I put into it, please go and donate more at Deaths for Ukraine. And, let us go over the 101K and then, let's see where else we might go. But I know a lot of you have already donated, which, is much appreciated. Yes, it was very much Jit. I went very far because turns out yellow shirts are not in fashion right now. So I needed to go to a big ass store. But anyhow, enough Toby stories. I already got myself in trouble with doing too many of these and we were late. So let's look at what's up. And so we already had sort of like a slow intro into the Elixir track by having Sasha here to talk with him because he's a very famous Elixir programmer and also, Erlang and the Beam itself. But now we have like pure dedicated Elixir talks coming up. And the first one is by Tatiana, which, this fits perfectly as actually co-founder and creative director at Clever Bunny Limited. We think alike. We like the same stuff. Tatiana is from Ukraine, actually, from the same city. I think I forgot to mention it before, but my friend Anton, he was also born in Kharkiv. And Tatiana will tell us a bit about this herself very soon. And it is a fascinating story about onboarding a team on Elixir, what to look out for, what to learn. So if maybe you want to introduce Elixir at your company, to your team, or you want to learn Elixir, this talk should be perfect to get you started. So hope you enjoy this talk.
My name is Tatiana Dushenkivska, and this is a picture of me in Ukraine before the war, in the city called Kharkiv, where I grew up. The main square in the city used to look like this, and now it looks like this. War brings destruction and anger. War doesn't have winners. War does not determine who's right, only who's left. That's why every day I wish for peace. I wish for peace worldwide. In my heart, I believe that concentrating on creation, improvement, and restoration would make the world a better place. So today, I would like to talk about becoming a more confident programmer, a better self. Before improving myself, it helps to understand where I am on the learning curve. How good am I with Elixir? And how about you? Where do you think you are on the learning curve? You a beginner? Maybe you're somewhere here? Maybe you're an expert? What if I tell you that the learning curve actually looks more like this? This curve called Dunning-Kruger effect, and it was inspired by a crime. In 1995, MacArthur Wheeler robbed 2 banks in America in broad daylight. He was surprised later when he was arrested, as he believed that covering his face in lemon juice would make him invisible to the CCTV cameras. Inspired by not only his incompetence but also his lack of awareness, researchers Dunning and Kruger ran a series of studies to see if lack of ability is linked to low levels of self-awareness. What they found was interesting. The less a person knew about something, the more confident they were of their abilities. On the other hand, the most competent tend to underestimate their abilities, and this is often referred to as the burden of expertise. In an article called Unskilled and Unaware of It, the Dunning-Kruger effect was born. Today, I would like to share with you a challenge I was faced some time ago. I was asked to help a team of developers to navigate across the valley of despair to the slope of enlightenment. The challenge was to help the team of 5 to become confident with Elixir in 3 weeks. The team already had experience with Python and Go and had begun their journey with Elixir. They were remote, and extra challenge was that the team needed to keep delivering at work. I had doubts about saying yes to that challenge, as I had doubts whether I would be able to help. What if I just waste their time? What if I don't easily understand their business needs? What if this or that? But I knew that I'm a little bit further along the curve, so I should be able to help. So, doubts aside, challenge accepted. Now, if you were faced with a challenge like that, where would you start? How would you help a team of 5 to become confident Elixirists? This is what I did. 3 steps to achieve the goal. Step number 1. Understand what gives me confidence with Elixir. 2. Identify the team's overall knowledge and understanding with Elixir. 3. Build team confidence. So, what gives me confidence? Confident design and confident code. What do I mean by confident design? There are a few things I include in design. One of them is purity. Purity is understanding of concept of pure functions and striving to separate pure code from impure. It's one of the first concepts you come across when you start learning about functional programming, and it's the one which can easily slip away from you when you work on real-world projects. So, why should you care about writing pure functions? With pure functions, dependencies are explicit. Pure functions are portable because you can easily copy a function from one module to another. Pure functions are testable, and it's easy to pass in an input and evaluate on output. Pure functions are memorizable because the answer of the first invocation can be remembered, so function only needs to be called once, which makes them fast. Given the same input, you always get the same output, and thus referential transparency is preserved. This makes pure functions easier to write and reason about. This contributes to a code base that is more maintainable. They help writing parallel code. We can run any pure function in parallel since it does not need access to shared memory, and it cannot have a race condition due to some side effect. And what else gives me confidence? Understanding what data types are available to me and when to use them. I would like to share with you how I choose one data type over another. It's idiomatic elixir to use map to pass parameters and to use keyword list to pass options. The question is, why would you use one associative data structure over the other? Associative data structures are the ones that can associate a certain value or multiple values to a key. So why would you use keyword list instead of a map? The answer lies in characteristics keyword lists hold. Can you name them from the top of your head? I've prepared a little game of discovering characteristics to test the knowledge. What would this return? Syntax error. In keyword list, keys must be atoms. And what would this return? One. It's because keys are ordered in keyword list. And what would this return? In keyword lists, you can have more than one key with the same name. These characteristics are what prompted keyword lists to be the default mechanism for passing options to functions in Elixir. Vector library makes use of these characteristics to provide an elegant DSL for writing database queries. A good understanding of types helps me write idiomatic and performant Elixir. Code organization is important in giving me confidence too, because well-organized code is easy to understand and maintain. I like to organize the project using umbrella applications. Why organizing in umbrella applications? Well, I have 4 reasons to do that. Within an umbrella, the dependencies for each application are clearly defined in the mix file. Let's have a look at an example. Here we have 3 applications under the umbrella. Auth Web has the sole responsibility to handle web requests. Auth sole responsibility is to handle authentication, which is done using Guardian at the moment. To store any data, Auth will talk to the store application, which has Actor as a dependency. Auth Web doesn't know anything about Guardian, Actor, or underlying Auth implementation. Auth doesn't know anything about Actor. If we were to replace Guardian and use something else for authentication, Auth Web wouldn't need to know about it. Another reason to use umbrella applications is that they allow you to design with deletability in mind. That's an idea borrowed from Greg Young. The idea is that you can delete or replace functionality quickly. Let's say we want to change our Auth app to use custom mechanism for authentication instead of Guardian. With current design, it's easy to do. We can write our new Auth2 app, which would use custom authentication. Then, when we don't need to use redundant Auth with Guardian, we delete it. The beauty of this is that Auth Web or Store wouldn't need to know about this change. This is how I see it. Imagine that you need to unplug something in this system. Would you prefer to remove cable from the left or the right? Another reason to go with umbrella apps is the ability to have an application per DDD context, DDD being domain-driven design. Using the same terminology in code base as in business makes it easier to communicate between developers and business people. Here is an example of using ubiquitous language within the umbrella. In Oath application, our user called user, but in the games department, they don't refer to them as users, they call them players. Similarly, in the shop, we have customers. In editing department, we have authors, but all data is stored in the same users table. Last reason for using umbrella apps is not applicable to everyone, only for those who are deploying using releases. You can have lots of application under umbrella, but in release only include what you need for particular functionality. For example, in Elixir Flashcards project, we have many applications, as you can see here. If you want to deploy a new version of our editor server, we will only include a subset of the applications in the umbrella. It will be a different subset for a game server and different for a shop server. However, we get to keep the whole project inside one GitHub repository, which works well for us. So, clear dependencies, deletability, separation into contexts with ubiquitous language, and deploying with releases are the reasons why I would go with umbrella applications. However, there are times when I wouldn't go with umbrella applications. If it's a simple project, umbrella applications may be an overkill. Also, if I don't know how to break my project into umbrella applications, I would start with monolith and refactor when I have a better idea of what is a good abstraction. The last thing you want is to end up with circular dependencies. Bad abstraction is worse than no abstraction. I like the applications within the umbrella to have a good README and clear, well-defined interface or public API. There are few pros of using interfaces. You can define clear public API, taking advantage of Elixir's ability to add nice documentation and specification to functions. Here is an example of the public API for Oath application. With module doc, we can describe the kind of functionality available in this context. Then list all the publicly available functions with their docs and specs. In this module, we use delegate to delegate functionality to subcontexts. Another reason of using interfacing is that they allow two teams to work simultaneously as far as they define a contract upfront and keep it. Another advantage is that keeping the same contract allows replacing underlying implementation and things will still work. However, some of you may think that organizing projects in umbrella applications is useless, as there is no really a way to enforce all calls to the apps to go via that interface. Umbrella applications with clear interface. And inside context, I strive to write as many pure functions as possible and push impure stuff closer to the boundary. Another thing I strive for is to create a struct when boundary is crossed and pass that structured data around within the application. That saves me from passing some invalid data down the stack to see it breaking things. I find that validating data and creating a valid struct can save me from a few errors. Also, if data is invalid, I can return a nice message to the user straight away and keep business logic clear from formatting error messages. Here is an example coming from job application, where we create a new order struct and then passing it around the context. I love using structs, and I have a few good reasons to use them. Struct provides a compile time guarantee, as shown here. For example, what would this return? A key error. And do you know what would this return? Here we use module attribute enforce keys. Argument error. Also, structs provide tighter type check, as they can pattern match on type of struct and function head. I know that not everyone in favor of this approach, which is fair enough. It's something I like doing when it fits. Like in this example, here we create an adult module where the age must be more than 18. And in drink module, we can pattern match on the struct to determine whether the person is allowed beer or not. However, there is a potential danger with this approach. It lies in how struct is defined. Let's have a look. Do you know what this would return? A function close error. And this one? An adult struct, which then results in a problem where teenagers and children are drinking alcohol. It's the same kind of problem as with interfaces. We can bypass going through interface and decide to call any public function we want in the application. With structs, we can bypass going through constructor function. You can add a guard clause here to check the age or agree with the team to comply standards of going through interface and new functions. But there is no guarantee that this would happen. And another reason to use structs is as it allows for composable and extensible pipelines. Ecto does it really well. So in summary, this is how I like to organize complex projects. Separate pure from impure, push impure to the boundary, convert data to structs as early as possible, and use structs inside the context. This is all good, but how about processes? I like them too. I tend to settle for a simple workflow, TTD implementation of the logic, then add state or concurrency by wrapping it into a process, then make it fault-tolerant by adding supervision tree. When working with processes, there are a few things I've learned over the years. One of them is that you got to restart Gen server with a new state, because corrupt state is likely to be a reason for failure. That's why restarting with a corrupt state would fail again. Once we exceed number of allowed restarts within given time, we could take our parent down, and as a result, the rest of the tree as well. Also, I like to extract functionality out of the process in most cases. It makes it easier to maintain, as extracting functionality into a module allows you to use an intention revealing names and ability write docs and specs to functions, which take care of accepting state and returning a new state. And it's easier to test, as your tests can now use ubiquitous language. Here is an example of the worker which takes care of implementing the game. You can't see it very well, but what's happening here is worker implementing a handle call to display next card in the game. Now compare this code to the version where state update functionality is out of the process. Here it is. It's easier to see the life cycle of the process. Purity, types, organization, and architecture gives me confidence in my project. Writing applications on the beam involves message passing between processes. In order to ensure applications remain decoupled, I find that event-based architecture is a good fit, not to be confused with event sourcing. What I'm talking about is event-based architecture, where you send events to a central broker and all subscribers of this broker receive and process events asynchronously. This architecture is called broker topology. With this architecture, you can decouple your applications. Being confident in the way you design your project is great, but it's also good to know that your software works now and will be working tomorrow. That's what confident code is about. We have our beautiful project in Elixir. Where would I start to make sure it works? Unit tests. I would have them in place by the time I finish my implementation, because I usually TDD my implementations. Next up, integration tests ensure the applications work together. For example, integration test would be test going from auth web into auth. To make sure auth web tests are fast, I would mock external dependencies from auth application using mocks library, for example. However, I don't recommend mocking the database. And with those, this is our foundation to protecting our Elixir code. And next up, I like style to be consistent with the rest of the Elixir community. And this is where format is great. Gridder will give me confidence that things are consistent within my project. With test coverage, I'll have an idea if I'm missing some tests. Next up are the serious guys. Dialyzer helps me ensuring that specs are aligned and help me find some bugs I wouldn't even think possible. Smoke tests are the tests which go through the stack, starting from browser making a request and returning a response. And to be super confident and help identify some edge cases, I would use property tests where it makes sense to use them. And when things go bad, debugging and tracing to the rescue. And with all of those tools, I have the tower protecting my beautiful Elixir code, and I have a confidence that things do work. And that's what gives me confidence. After understanding what gives me confidence, I had to remind myself why I did it. So I can help a team of 5 to become more confident with Elixir. So step number 2 in my challenge is to identify team knowledge. It's hard to help someone if you don't know what they know. To identify where team is on the learning curve, I've used a few techniques. By reviewing the project, I get an idea how Elixir is used, what practices and concepts are followed. The things I looked at during review are code organization, design patterns, consistency. What would I look for when it comes to organizing code? Things which make me confident with Elixir. Here is an example of my findings. It was important to mention that what team already is doing well, not only things which can be improved. And once I've identified what is good and what can be improved, I had to share feedback with the team. One of the things I've picked up on was using nested cases and if-else's. So here's an example of giving the feedback around nested cases. I would pick up a code example from the project where improvements could be done and show it to the team. After looking at the example and understanding what code is doing, I would suggest an improvement. There is a simple way to determine if you need to refactor. You stand back and you squint. If it goes to the right a lot, it's time to refactor. Then I will leave to the team to decide whether they are happy to adopt my suggestion or ditch it. By reviewing the project, I get to understand where the team is on the learning curve. Once I reviewed the project, I've used another tool from my toolbox, the flashcards. Flashcards contain a question on one side and answer on the other side. They're great at identifying knowledge gaps around terminology and Elixir API. Well, let's see if you have any gaps in your knowledge. What would this return? Okay. What do you think this would return? Undefined function error. I sometimes forget this. That's the real function. Let's return a string. By using flashcards, I get to understand where each individual is on the curve. Also, I was pair programming with one of the developers from the team at a time on a piece of work they were doing at the moment. It was a remote pair programming using Zoom. You left the meeting open to anyone to join, so anyone can see what we're up to. The agreement was not to interrupt the flow of the pair. After pair programming for 3 hours with each developer, I get a better idea what each individual person areas of work to look at and what their personal goals are. Pair programming helped me understand how each team member is thinking when coding. After pair programming, I realized that my initial plan of covering some topics had to change, and I had to make sure the fundamental functional concepts such as purity is well used within the project. So initially I thought this is where the team was on the learning curve. Actually, it was more like that. After identifying team knowledge, the time has to come to fill in knowledge gaps and build team's confidence about using Elixir. And how to build team confidence? Via mentoring. Mentoring is not teaching or lecturing. It's about helping individuals to define a goal, come up with a plan, and provide support and motivation on the road to succeeding with achieving the goal. There are 3 techniques I've used while mentoring. What is the first one? Flashcards again, this time as a revision tool. When you look at the front side of a flashcard and think of the answer, you are engaging a mental faculty known as active recall. Active recall has been proven to create stronger neuron connections for that memory trace. Also, they can be used with confidence-based repetition. Looking at the curve of forgetting, you can see that the more you recall something from the memory, the better it will stay in the memory. Confidence-based repetition is a technique of remembering an information by separating practice sessions in time. Also, I used presentations. Presentations help to share the knowledge with the whole team and to have something left for reference. Here is an example of the presentation structure which seems to be working well. This example comes from presentation about purity. Identify knowledge gaps with flashcards. It's important to only focus on things the team don't know. So what is the answer to this question? The team gives an answer. If everyone got it right, then skip the explanation. If at least one member of the team got it wrong, move to explanation. The important thing during mentoring is also record which cards has been answered correctly, so in the future you can come back to the wrong ones. For me, it was important to track progress and at the same time keep each person on the team happy, so I was recording the progress for the team, such as 4 out of 5 answered correctly, rather than pick up on a particular individual. Let's say 4 out of 5 answered correctly this one. In this case, I would go through explanation. Here we go. For example, current function is pure. Given the same input, it will always return the same output. Given 1, it will always return 2. On the other hand, this function isn't pure. Given input 1, it can result in 2, 3, or 4. After explanation, little test around purity in Elixir. Start simple. What is the answer here? Is this function pure or impure? This one? That one? This one? Cool. After answer what, it's quite important to discuss why. Can you think of benefits of using pure functions? And after answering why, it's time to move to how. How would you benefit from purity in real-world projects? We all know that most projects would need to contain impure functions to maintain state, talk to database, print to console, make HTTP requests. The key thing is to make as many functions pure and push impure stuff closer to the boundary. It can be done in 2 simple steps. First, identify pure and impure functions. Second, make as many functions pure by passing in required data. And then I would pick up an example from the project and walk through separating pure from impure. So in this example, we find the pure stuff and impure stuff. Then we pick up the impure stuff, move it closer to the boundary, pass down the ink by value, and then we do the same again. We find the impure stuff and pass it and move it closer to the boundary. And then our ink function is pure and easy to test. One step is to provide links to relevant reads, presentations, and so on. And once knowledge has been shared, we've used pair programming to solidify that knowledge in practice, identify new gaps to become confident with implementing theory in practice. While pair programming, I had to remember to provide guidance, not lead, but to concentrate on discussing various approaches to a problem, paying close attention to pros and cons of each. The key was to let the team make an informed decision about the approach they want to adopt for their project. Pair programming was a great place to share the way I think about the problem, some tips and traps I've experienced from working for numerous years with Elixir. And after pair programming with each member on the team on a particular task that person was working on, they all got different knowledge. So in a way, they were mentors to the rest of the team on that topic. And I, with help of flashcards, presentations, and pair programming, had a lovely time mentoring. I found out that there are a few tips for a successful mentoring. Ask questions correctly. I often would explain the subject and then ask, "Did you understand?" Often the answer was, "Yeah," and I just moved on. However, asking questions before explanation is more beneficial. Also, asking "Why is this like that?" "What did you understand?" instead of "Did you understand?" worked like a charm. And flashcards can help memorize things. As mentoring, not lecturing, it's important to remember to explain how and why something works and give options to the team to choose the best approach for them. Concentrate on good things and achievements as it's motivating. And one of the things which didn't work was not having a challenge for pair programming. It worked when the guy had something to pair on, some feature, bug fix, some other piece of work. And with those 3 steps, First, understand what gives me confidence. Second, identify team knowledge. And third, build team confidence. We were able to achieve the challenge and help the team cross the valley of despair and climb the slope of enlightenment to become confident with Elixir. And as a bonus, I got a really good feedback. Today, we have talked only about one curve, the big learning curve to become confident with Elixir. However, when you think about it, there are many small learning curves which you are in different positions on the curve. Maybe on some you're already a master, maybe others you have yet to cross the valley. If you haven't tried mentoring, I encourage you to become a mentor on a subject you know well and seek for a mentor on things you're yet to master. Why would you want to be a mentor? Well, it feels good to share experience, develops better understanding of subject, and as a bonus, as a mentor, you get to develop communication and leadership skills. Being mentee is also good, as your time spent effectively with the help of mentor, your learning is tailored to your personal needs, which results in you progressing faster and transition fast through the valley of despair. It looks like successful people can see value in mentoring and often thank their mentors in their success. Steve Jobs had Mike McCullough as his mentor. Let's help each other to become successful. Thank you for your attention and thank you for supporting Crave. And as a bonus, I would like to share with you something all Ukrainians learn at school. The blue on Ukrainian flag represents the peaceful blue sky. The yellow is for fields of wheat. Thank you for your time.
Wow, that was just so packed with, knowledge all the way. So many great things to take away. And, I've seen it a couple times in chat and certainly holds true. Like, that really feels like a talk that I probably need to watch back another time when I'm not sort of like moderating on the side and like really to fully grasp it and sort of like take all that knowledge in. And so, yeah, very, very happy for the talk. Thanks, Tatiana, for preparing it, and thanks for being here. Really, really great. Thank you so much. Speaking of thanks, it's time to thank our sponsors again. And because, you all give money, I hope you all give money, but you can also, donate more. And oh, wow, thanks, Cassie, for putting them in there. So, thank you, Frontend Masters, OSS Capital, Incredible Dev, Linode, Akami, and Stripe. And we also want to thank actually Lily's startup, Contender, because you might have seen our Twitter, and we're all busy here. And they're actually putting some great content out on our Twitter, and actually clipping some of the talks so that people get interested, watch the talks, and then hopefully also donate more money. So also huge thanks to Contender. And Cassie, did I forget anything? Producer in my ear. I think that's a sign of good Toby. Yes, thank you. By the way, everyone who tells me I'm doing a good job moderating, thank you very much. It is very encouraging. It's my first time live on Twitch, and coming up after sort of like the queen of like live streaming and coding in Cassidy was like a tiny bit terrifying, but you all made it much better, and so thank you very much. Speaking of which, here goes the next talk. And, I'm very glad to call the next speaker a friend, a colleague, a coworker. And by the way, the person that basically gave the spark to idea that I appear in this outfit, because I showed Victoria a picture of me in the suit at a wedding. She was like, wow, you look good in that. Maybe you want to wear that to the conference I'm seeing. And I was like, oh, wow, I could, yellow, blue, would be kind of nice. So, she also impacted the conference in that way, which is really, really cool. But yeah, she's very knowledgeable, just kind and human being. And she will talk to you about architecture, how to understand the code base, making it a welcoming and a friendly place. And she will also take our architecture at remote as a reference example, so you can also learn a bit more what she and I do mostly in our day-to-day. So please sort of give a warm welcome to Victoria and go enjoy her talk.
Hello there. Hope everyone is doing well, and thanks in advance for watching this. Today I'm going to talk about how having an architectural reference for your application can actually make your life easier. And before I start, let me introduce myself. That's me. I'm Victoria. I'm a backend engineer based in São Paulo, currently working remotely at Remote. And from the last few years, I have been shipping code in Elixir with no intention of getting away from that amazing stack. So that's pretty awesome. I'm really enjoying it. And I must say that one of my motivations here was that desperate feeling that eventually happened to you when you're trying to understand a code base for the first time, or when you just join a new company or project and start working on a new feature and shipping code, and you might feel lost. It feels relatable to John Travolta in that Pulp Fiction scene. So you don't know exactly where to place stuff, how directories are kind of organized. Feels relatable that someone eventually will experience something like this, especially when starting on already consolidated systems, bigger ones. And there is also a bunch of memes across the internet proving that I'm not alone in this. Anyways, jokes aside, there are a few simple concepts that can be useful for creating a more welcoming and friendly code base that will enable more engineers to contribute on it in a more efficient way. I will be using Elixir and the architectural reference that we have at Remote as example. First, have patterns, doesn't matter which. I believe this is also a general consensus of the importance of having a more standard way of doing stuff through the code base. Initially, it does not matter exactly if they are the best ones or the perfect ones, but it's worth to have 2 or 3 ways of implementing kind of the same idea. This is a simple starting point, but I've seen it get very much relapsed. I think it's something to fight for on code reviews and keep a standard. And also keeping the silent rule of having at least one person mentioning DDD in a conference. The general concepts of domain-driven design presented by Eric Evans in his respective book can also create a safe ground for software development. And no worries, this is not a talk about DDD, and probably some folks here already master it or is already tired of listening to it, but just in case, it feels like it's worth pointing out that it brings relevant concepts about reflecting businesses into code and a few patterns that make everything more organized and even scalable from the technical and product point of view. So just focusing on the big picture of DDD, what we want here is to guarantee that the application design resonates with business domain and its rules. Okay, but how do we translate that into code? And then we can go for 2 main central concepts here, which is the ubiquitous language, meaning that business semantics are reflected on code, for instance, on entities names, service modules, and so on. So for example, we can have a final user on the platform, but the user can either be, for example, contractor, employee, employer. So they shouldn't be named just as user. So let's be clear about it. And the second concept is bounded context, in which the idea is to keep a cohesion of domain concepts and actions, kind of having clusters of it. In this example, on the image from Martin Fowler website, a well-known image, we can see a differentiation between the sales context and the support context. I would focus, for example, on the customer differentiation, where they can even have the same attributes, but there is at least one level of differentiation between them, business related and regarding its type. So they're not the same customers, probably they might have different actions related to them. So given all that, sometimes you just want to go for patterns and ways to group our application in different namespaces and stuff. As a rule of thumb, it's more effective to guarantee that the understanding of main concepts of the business and to have clarity on the nomenclature and then reflect and group across the code base. Next idea here is that the support and general guidelines of a framework can also help on code organization and to create a better separation of concerns too. Frameworks are heavily used, they bring the easiness of some already implemented general features that are relevant for production code that we don't want to keep rewriting or reinventing the wheel. There are a bunch of frameworks that follow different architectural styles, conventions. In this presentation, I'm focusing on Phoenix. Phoenix uses the model view controller structure. And if you go to the Phoenix website, they point out a very interesting idea, which is the MVC without the mess. And then you go through the tags and documentation of it. Hope you do it later. And you see that the idea of bounded contexts also motivated Phoenix guidelines, which is great, right? It's aligned with what we want here, or at least what I want here. And how it goes is that Phoenix adds, let's say, an extra layer in the MVC architecture, which is Phoenix context. I believe it can be bold here and call it MVCC. And it wasn't always like that. It came by when Chris McCord, creator of Phoenix, in the ElixirConf of 2017, announced that Phoenix was no longer going to keep the module namespace, which is also relatable with the Ruby on Rails framework structure, if you have a Rails background. And instead, it was going to separate the data structure namespace, which is going to be called schemas, from business domain logics, which is going to be called contexts. So we transitioned from having one single namespace called models and having two different modules called schemas and contexts. So let's take a sneak peek at it. Well, and since remote is a global HR system, well, for now, I would just go with a relatable example. So let's say I want to give support in my platform for contractors to create invoices to send to their employees related to the work that they done in a respective moment. And for that, I will use the Phoenix generator, which is scaffolds things for us. And it's just for the sake of the example. So I'm going to create contractor invoices that is going to have two basic fields, description and amount. And here's the result of the schema created, where we can see that it has basically the declaration of the variables for my contractor invoice and a basic change set validation. So now let's take a look at the generated context. The context, it has a group of functions. This is first part, and then second part of it. It has already some predefined functions that are more related to basic database actions that can also like general operations that sometimes we go when scaffolding stuff. So, and also motivated by the DDD concepts, the context was a way for defining the API domain. And designing with context is the idea to give a foundation to grow your application using a discrete, well-defined API that exposes the intent of your system. So scaffolding gives you those basic actions. Additionally, we can get a glimpse of what the application does and its feature set by just exploring the application directory structure. In short, Phoenix context can be an interface to abstract your domain logic. And it's also a way to vertically separate your application, focusing on business use cases. And when I say use cases, which is a bit old school term, if you developed using Java, I think it's going to be relatable. But what I mean with that word is from the user point of view, how the system should respond to a specific action or request. But sometimes just this context schema differentiation might not be enough. As I said, Phoenix has the MVCN context. So basically everything that is neither on the view or in the controller goes for the context. And context can grow a lot in an undesired way because it can have data validation, authorization logic, a bunch of external requests, notifications, it can trigger processes, has event tracing. So it can grow a lot. And probably you will notice that you will need to organize better your context and put high-level use cases in specific modules. So my first tip here is that maybe first, don't use generators. Scaffolding is nice when you're learning, but probably for production code, it's not going to be the most mindful decision. As I showed, the generator goes for 5 default actions: list, get, create, update, delete. But depending on how those actions should behave, they might have more side effects than just database persistence. And so my second tip here is to leave Phoenix context just as an interface for database operations in a more atomic/pure way. What I mean by atomic is a single unique action independent of further logic as a pure function, right? No side effects and stuff. And I'm basing myself here on the dependency inversion principle, in which high-level modules should not import anything from low-level modules. So we're considering database something low-level, and we are using context as an interface for it, and creating that boundary. Boundary are lines that separate software elements, basically, and they separate things that matter from things that don't. So high-level components from low-level components. If a high-level component depends on a low-level component at source level, changes in the low-level component will spread to high-level. Therefore, we place a boundary between the two, using polymorphism to invert the logic flow. So that's the idea here. So what we should leave for context, in my opinion, in order to keep them more concise, is mostly database operations. So also you can have some sort of specialization on those functions. So you can have a more specific query, not only for basic listing and whatsoever. Right, but what about the rest of stuff, right? Everything that we listed that could go for context, and now we're changing that. First idea here is to create a separate module for each specific or complementary action of a use case. So let's call them services. And let's go also for creating atomic services that can also be used for different services. We'll try to keep them more atomic in a way that they're going to do only one single thing. And here I'm also using another solid principle, which is the single responsibility one, in which a module should be responsible for only one thing. And for the sake of having patterns, let's go that we should expose for those services the same public function. We can name it call as a suggestion here. And also we should group services in the same bounded context, probably inside a default namespace kept in objects here like services. So let's go for examples of services that we can create for this flow that I just suggested. So a contractor wants to create an invoice, and probably the way that we are picturing the flow, it's not going to be only database persistence. So first, we need to create the record on the database. Then let's say that we need to generate a PDF file for it, save that on our S3 bucket or whatsoever, send an email to the contractor and say, hey, we generated your invoice, and then persist an event on our system in order to keep track of things that are going on. The first action, the invoice creation on the database, we could actually leave for the context, for the contractor's context, but for those 3.5 actions, we could, each one of them could be a single service. So let's go for an example for one of those topics there. So let's use the generate invoice PDF as example of service. So here we have this module. It basically call generate PDF that could be a more general service that could be reused in different modules. And we're calling here to generate the PDF, and we are going to track that this was generated. Of course, that we might need to format that PDF into invoice format, so there might need some levels of specialization here. And then we could have a high-level service that would glue those other service calls because it makes more sense in terms of action. So let's go for a service that is going to be responsible for the invoice creation. And that service will call the context responsible for persisting the database, will call the PDF generation, will send an email, and will persist the event in order for us to track that invoice got created. So in summary, services ideally should be reusable between modules, or could be services or modules that are more external to it, have only one single goal, expose only one public function, and create and modify data. That's the main focus here. We want to be very explicit about data creation and modification and all the side effects of it. So now that we have atomic and reusable services, maybe they will be called by what we say use cases. So yeah, I'm creating a new layer here. We're creating a new layer here called use cases, or call whatever makes more sense to you. If use case is too much of an old school or something that you don't like, I think it's a good name. And it's going to be a slightly higher level layer responsible for orchestrating all the calls to the services and composing the expected outcome for its action. And each use case can be organized by domain, subdomain, and it should contain all things called relatable actions. In the example for contractor use cases, let's say that we have two use cases for now, invoice creation and invoice update. Those are two main use cases. For now, those two use cases will only route a call to two basic services, which is the create invoice service or the update invoice service. Eventually, the use case will have to orchestrate further service calls, and this one is a very straightforward example. And the idea of this layer is to be an orchestrator that encapsulates the use cases. And what about stuff that are not under the use case scope? Well, use cases are not responsible for creating and modifying data directly, and also do not contain business logic code, otherwise leave it to a service. It should be mostly working as a control flow. And eventually, those user cases will be called, let's say, bar controllers. And what services then would make sense to call at controller level? In my opinion, from what I've seen we have at Remote, things like authorization policies, sanitization of request params is something that we want to pop right away, right? We don't want to propagate bad parameters into, for example, context. Pagination, the return object for a given request. And you might ask, like, why don't we just delegate the responsibility from the use cases to the controllers? Like, why all of that lasagna? And the idea here is to have this use case layer as a domain level orchestration and leave your controller for framework level orchestration. Not always the controller is going to be our main point of contact for the system too, so we can end up reusing use cases too. And to connect all the dots regarding this MVC / clean architecture idea, let's also imagine the controller response. From the controller responses, we might expose entities from our system, but do we want to expose everything like internal IDs? Probably not. this is not a good thing to expose. So let's create response modules for that then. And what I mean about response modules is basically they're going to be responsible for composing the data structure response of the controller, and they should be reusable. And again, using the same idea that we had on services, the same pattern is like let's use them to expose only one public function. Let's say build. Let's name it build, but you can name whatever you want. And they should, for example, in this case, return a list or a map with data structure, and they shouldn't contain any action logic or call other services or use cases. So they should only be responsible for actually building the data that you want your controller to return. So this is an example of invoice response, because when we generate an invoice using Phoenix, it automatically generates an ID for you. We don't want to expose that ID. We're just going to expose amount and description. So those are the safe fields to expose. And we're using this module basically to build up that. And wow, great. So let's take a bigger look and understand how all those pieces are connected. So you can see that we're maintaining like the controller, the view, and template, which is also default from Phoenix. But then we're adding those 2 extra layers of use case that works as an orchestrator for service calls. Services can call themselves. They are more atomic, focusing on data modification and data creation. Also, there are more general services that can be called by the controller. As I said, but pagination, sanitization, those can be atomic services that can be called directly from the controller. They don't need to go through use cases. And also we are associating the view to a response module because we don't want to directly expose that. And we want to have also a pattern for that because this can be also reused. And the directory structure also gets a little bit clearer with that, having the use case namespace, the service namespace, and the response namespace. Also keeping the context idea, the schema idea, and high-level services. So it gets really clear to understand what's going on by going to the directory structure of the application. And yeah, that's the main idea here. We came with all this lasagna application, not that much of that lasagna, but we also created a better separation of concerns and a way to add code that reduces the cognitive load for scaling it when we have multiple developers deploying on the same code base, for example. And also can be a standard for multiple services in case you're already going for a microservices architecture, if it's the case. And that's it, folks. Thank you for your time. I hope this was at least insightful and relatable. If you have any questions, suggestions, comments, feel free to ping me and reach me on LinkedIn, Twitter, whatever you want. And that's it. Thank you. Thank you so much for supporting this conference, and see you around. Bye.
Oh, wow. I think Victoria got cut off there a little, but I think she wanted to say donate more money, give more money to Desk for Ukraine to help Ukraine. I'm pretty sure that's what she wanted to say. I know her pretty well. And thank you, Victoria, very much for the amazing talk. And also thanks, Chad, for all the interaction, all the questions, all the discussions about architecture and everything. It's always a very good topic. And yeah, I'm very happy. So this gets us through sort of like 3/4 of the day. So this was the main Elixir section of the day, and we'll go on break very soon after I stop talking. And the last part will be about open source, but also a bit of Elixir. So the next talk after this will be a Q&A that I did with Jose Valim, who's the creator of Elixir. So it will be about sort of like open source life and how he created Elixir and why but also, Elixir itself will be a topic. And then we'll have another really, really great talk about, opening doors with open source by Anjana. So yeah, we'll go on break for a bit more than 20 minutes, like 22 minutes. So we'll be back here at around 20 past. That should be, oh, wait a second. No, the clock time breaks. So it will be, I think, 2020, actually, UTC. And for me, it's 2220 Berlin time. So thanks, donate, go make some noise on Twitter and whatnot so we get more donations. And then see you back here in about 22 minutes. Thank you.
Yeah.
Well, hello. No worries, we're not starting again. And Cassie, we did have this topic already. Yes, for you, this music is great to work to, but I need some punk rock. I need some hardcore. I need something that pushes me on and keeps me going. Hot water music in Boys It's Fire in Berlin in, I think, September. Anyone? Okay, I'm sorry. Too much trivia, but this is also what this time is for. And I think we also cracked. We cracked 101K. So yay, that was our next stretch goal. I'm not sure if we can, get to another one, but I'm happy we did that. And while I'm here and while we're on that topic, like I always call for the donations here, and that is great. And donating for our platform is cool because it shows us what we do works. It's not just the 15K that we set, and we went over 100K, which we never imagined in the beginning, and which is amazing because the money will be able to help many people. That said, if you don't like the organizations we give money to, or you want to give all of it to like one organization or something, not like the 8 that we support, do that. At the end of the day, I do not really care. Like I'm happy to see like how much money we raise, but at the end of the day, what's most important is that money arrives in Ukraine and helps begin. Not just money. We also all talk about money all this time. But if you live close to Ukraine or where there's Ukrainian refugees, you can also go and help directly. If you speak Ukrainian or Russian, you can translate. You can help out in other ways. You can help pick packages that are then sent to Ukraine, and you can also host some people because there's not a lot of housing. I think like in Poland right now, something close to like 2.3 million Ukrainians have fled to Poland, and lots of families and people host them and really show their support. And so that's another great way if you can afford, because you need some space and everything. But there's many ways in which you can help, and whatever way you help is much appreciated by me and by everyone. So thank you, everyone. With that said, I think we're at 20 or even 21. Speaking of which, the next thing is something that I think many people have been waiting for, although our viewership dropped a bit, but I know it's late in many of these places. And our next speaker is actually living in Poland, and his name is Joseph Valim, and he is the creator of this Elixir programming language that we talked so much about. And so what we did is we opened up questions to the community, and I also tried to dig deeper on some of these, and then we asked him the questions, talked to him a bit, and I think it's a very interesting Q&A and conversation. So in order to do that, we'll see it now. I'm just going to change real quick, and then we'll be right back and have the Q&A. Bye! Hello and welcome. This is the much anticipated Q&A with José Valim here at our Desk for Ukraine conference. If you don't know who he is, José Valim created the programming language Elixir, which a lot of us really, really love, like 10 years ago or something. It's been quite a while, and before that he was very active in the Ruby community, Rails. Lots of people use Device, and we just want to talk about him to Elixir and everything. So hello, Jose, how are you doing?
I'm doing great. Thanks for having me. I'm really glad that you're organizing the event and I have the chance to participate.
Thanks for doing this, and thanks for being here with us. So I just did the intro. Did I forget anything major that you would want people to know about you? Maybe so for some it will be the first time ever seeing José Valim. So what else should they know about you?
Yeah. So the other way to go about it is that I am a Brazilian guy living in Poland for more than 10 years. So Elixir was created while I was used to joke during the Polish winters, because I would not leave home. But yeah, I've been working on Elixir and ecosystem for quite some time. So that's definitely the main intro.
Actually, when I got to know of you many years ago, this was actually quite mystifying to me, because there was this really cool guy in Poland with his company Platforma Tech, and then I was like, but I never met any of them, like there's this huge company in Poland, none of the Ruby events, I met all of them, and then it took a while to realize that I think the rest of the company was in Brazil, right, and you were the only one in Poland. So for years, I was very confused about all of that. But that's me. That's not part of the official Q&A. So I think we already kicked it off well, because lots of the questions that we got were actually about sort of like the inception of Elixir. Like lots of people seem to be really interested in that. And so one of the questions that we got was, what was the main drive when starting Elixir? Was it some curiosity? Was it a frustration? Or what is it that you wanted to solve by creating this new programming language?
Yeah, this can go really long. So I'm going to like summarize the elevator pitch version. So I was working on writing concurrent software or writing concurrent solutions in Ruby at the time. I was not happy with how the code would look like, with the bugs that would appear, how I would solve them. I decided to explore solutions. So at the beginning, I was like, hey, maybe there's a good way of solving this elsewhere, especially because this was more than 10 years ago. Everybody was talking about concurrency, even back then. So I was like, let me study. And then I say, when I started studying, I found like 2 points where that changed like my programming career. The first one was when I found functional programming, because I realized that many of the bugs that I was running into, they would simply not happen if I was using like a programming language that would favor immutability. And most functional programming languages, or probably all of them, they do favor immutability. So I was like, okay, that's great. And then I found Erlang Virtual Machine, absolutely fell in love with it. And then I was like, okay, the next software I write is going to run on this virtual machine. And one thing led to the other, and I was like, okay, I think I can bring some new ideas to this, to this ecosystem, to this virtual machine, and that led to Elixir.
Nice, thank you very much. I would like to take a bit deeper there. So, like, what in your mind are some of the main ideas that you brought to like the Beam ecosystem and the Beam virtual machine?
Oh, that's a very good question. I think so. One of the things that I still really love about Elixir is what we call the protocols. So, so one way that you can think about it, I mean, depending on where you're coming from, I'm going to give you many examples for the people who are joining us. It's kind of like, it's not really, but it's the closest thing. It's like duck typing in Ruby and Python, but way more explicit. It's like interfaces in Go, type classes in Haskell, protocols in Clojure. But I think this concept, the idea of say, hey, give me anything as long as it obeys, like give me any data structure as long as it obeys a contract. I feel like this is such a powerful idea that I use every day. And for me, this is a very important concept that is part of Elixir. And also, and there are other things that are more like, there are some that are more debatable. So like the metaprogramming aspect, right? It's a little bit like it can be used greatly, but it can also be abused greatly. And there are other things that is also more about, like the focusing, like putting a lot of effort and attention on the getting started experience and make people, make the whole experience of like getting to hear about Elixir at the first time and then put in production, trying to make that as smooth as possible. So I think those were important contributions. Yeah. Or important ideas that I've worked on, like, there were, some of those things, they were of course happening already in the Erlang community too, right? With I really enjoy Fred Hebert in the, if I sorry if I mispronounce his name, like in the Erlang community and all the materials that he write and contributed as well. So, but yeah, those are the things that like I worked on and brought them in and with me. Yeah.
It's very, very interesting to hear you say, because like, when you say that you use protocols every day, that makes me feel like I underuse protocols because I definitely do not use them every day. And so I have another follow-up to this, if I may, is sort of like, what is maybe, one, feature that Elixir feature that you see sort of like underused in the world, where you often sort of like come to, like, you look at the library and you're like, oh, this would be so much better if it used X. Maybe let's first go with this and then have a follow-up.
No, but that's the thing, right? Like you use protocols every day. You use them. You're using them all the time, right? Like, well, every time you are using IX and something prints there, it's a protocol. You are rendering something in a Phoenix HTML page. There is a protocol there. So I'm not defining protocols every day, but I'm using them every day. And I think that's the important difference. And there are some things that, like some abstractions, some ideas that are really enabled by protocols that would be tricky to have without them. So yeah, so regarding a feature that is not used, I'm not actually sure if I can come up with an example. I think like the main features of the language, because like the main features of Elixir, if we take like protocols, but everything else, right? Like processes, pattern matching, it all comes from Erlang, right? Which is why I didn't mention them before, because we were talking about like what Elixir brought to the table. And I think like there is really good usage of those features, and yeah.
Okay, cool. And on the other hand, is there maybe sort of like a feature that you think is overused, not just of Elixir, but like everything that Elixir brings? So also pattern matches, processes and everything. Do you see something that maybe people are a bit too eager to dive into, and another sort of like simpler solution would usually do the job?
Yeah, I mean, they are like one of the things is that I think we have always tried as a community to notice like what we would consider to be like bad patterns and try to correct our course. So course, maybe, anyway. So for example, one thing that we could have said is like, people like abusing configuration could be one of them. And so, like we would use configuration when we should not, use things at compile time. But like 3 years ago, we noticed like, hey, this is a really bad idea. There were people saying that's a bad idea. And we kind of like were able to autocorrect a lot of that. And now if you go to the documentation, our library guidelines is saying, hey, you should not be using configuration. So we have like an official reference to point people to. So I think a lot of that helped a lot into like say, hey, if this is bad. So I think at a point, I don't see it happening as much as before. Right. And then there are other things that, so for example, recent Elixir feature that we added was 2 new functions in the kernel module, which is the module that is there by default for everybody, which is then and tap, because people that are writing long pipelines, and the pipeline's always about like piping to the first argument of the next function, but sometimes people wanted to pipe to the second. And my advice has always been like, if you need to do that, like write a private function or something like that. But nobody was doing that. Well, nobody was following my advice. So this is something that I would complain in the past. Say, hey, you should not do that. And but I realized at some point, like, there is no amount of warnings, documentation, interviews that I could go into that would get people away from doing that. So we introduce like then to make it easier for you to say, hey, I want to do something slightly different on this part of the pipeline. So, so that's something that, like I would, a year ago, I would say, hey, you should stop doing that. But now we have like, I can still say stop doing that, but because now we have a proper way of doing it, people had already stopped doing that because there is a better way that we can kind of like everybody agree on, yeah, that's better, So yeah, I'm hoping we are fixing the you shouldn't do this along the way as we move forward.
Cool, thank you. I must say that's always something that I've really appreciated when learning Elixir, sort of like the pipes, because what it makes you do is sort of like, you think about what is sort of the main argument to my function, what's the main data structure that I want to work on. And that has actually sort of like changed the way I code in other languages, because it gave me a better understanding of, what should the order of, arguments be. So I always try to follow your advice. So I love small private functions, but yeah, I know that everyone does. Okay, cool. So another question that we've got was, Elixir is already 10 years old, as we just mentioned. So first, congratulations also from whoever asked the question. Did you ever imagine it would become this big? And where do you hope to see it in another 10 years?
Yeah, so the answer to the first question is kind of going to answer the second question. So I didn't imagine that it would get this big, but not because like I didn't think that it would. It's just that I just avoid thinking about those things in general. Like, of course, there is a plan. There are things that I want to do. Like, I have been working for the last year, a little bit more than a year, in bringing like Elixir to the like numerical computing, Elixir running on the GPU, working with large amount of data. We having like live book, we have been putting a huge amount of work on this. And of course, there's a plan, there's a vision, there's a place where I want to go. But I don't think like I think on what I need to do. I don't think like, oh, what is it going to be like when I get there, right? Like I know what I have to do, so I do that, and that's it for me. The rest doesn't come really much into the equation. And I think at the beginning I was just to say that that's for like, like for defense mechanism purpose, because I think a new programming language statistically is most likely to fail, to not see like large adoption. So I think it would be like kind of silly to like to expect it to grow somewhere, because if you're going to have like a realistic expectation, you're going to say, well, it's not going anywhere. And that can be demotivating, right? So I was like, I'll do what I gotta do, and that's it.
Cool. That is a very pragmatic approach to sort of like working and designing a language. I love that. So if we look into the other direction, basically, not sort of like next 10 years, but a lot of people have asked a question sort of around this. So I'll pick one of them. I suppose you asked this a lot, but if you could redo Elixir from scratch, is there anything you would change fundamentally?
Yeah, so it's very tricky, because so I use this metaphor elsewhere. It's kind of like building a language, it's like kind of like a Jenga game, the one with the blocks. And it's not like you take one block, right, and like, oh, I don't like that feature, and then I'll take it, right, and I'll replace this. It just isn't really like that. Like if you, I mean, sure, for smaller things, yes, but if you're talking about like the language thing, they're all connected. So like every time I would think like, would I do something different, it has like so many repercussions. Like it puts me in a rabbit hole where I'm like, well, then this would change, and then I'm like, well, this wouldn't be Elixir anymore, right? It's like, so I also like I've made my peace with it, right? It's like, well, maybe I'll do something different, but it just cascades into so many things, different opportunities, maybe changes a little bit the compatibility, maybe some patterns that we like today would no longer be possible. So there are always these questions like these. Like, so for example, not that I regret, but just to give an example, right? Like, well, what if we didn't have optional parentheses, right? Even for Elixir today, like we have kind of agreed mostly as a community that we want to use parentheses and leave them out in some places, and tools like the formatter help enforce that. So even if you say like, well, what if we don't have optional parentheses, or we restrict them even further, like only inside do expressions or something like that, right? It's just that it changes. Like when you do that, there were many decisions that were based because the parentheses were optional, then they no longer need to be there. And reevaluating this all is like, it's a big impact. It's a big change. The other one that I think about is like the keyword syntax, for example. Like, should the keyword syntax be different? Should it be not? So yeah, so like, and again, it's a cascading effect. So yeah, I think about it from time to time, but I think there's small change. If there's something that I don't like today and it's small, then I'll fix it today, right? But the big ones, it is what it is. I've made my peace.
I know, we've talked about this before, sort of like the idea that you don't see, I think, in Elixir 2.0 coming along like anytime soon, so you don't want to introduce any breaking changes. But it's more like, if you didn't have to worry about breaking changes, what would you do and what would change? And I would actually like to ask a bit more about one of the things that you mentioned, because we also got quite a few questions about that, especially since it's a bit of a more not hot topic these days, but it has a bit more attention.
Is it a dot?
No, it's not the dot, like something that you already mentioned. No, not the dot. No questions about the dot from me, but if you want, we can talk about it. No, it's a keyword list and the maps, because sort of like Erlang changed its default recommendation from, I don't think they call them keyword lists, but the list of tuples, changed it to maps.
Yeah.
And and in Elixir, it's the keyword list, and the keyword lists have the fancy syntax where you can leave out the brackets and everything.
Yeah.
And so we received some questions about like, about changing it, or maybe also my question would be sort of like, why not change it?
Yeah, so well, regarding the dot, I'm going to publish an article soon. So if somebody's wondering, if somebody was like, yeah, I wanted to ask about the dot, there's going to be an article on the Dashbit blog soon. But regarding maps and keywords, we had this discussion. We had the option to default to maps, because when maps were added to Erlang, it was before Elixir 1.0. So we actually discussed this. And there are actually important properties for the keyword lists that we use today. Erlang doesn't use as much that we use today, because so the nice thing, like, so we have lists, right? And we have maps, right? And keyword list, it's kind of like, it's the child, is sitting in the middle. But what makes keyword lists interesting is that it adds properties that maps cannot have, and they are basically having duplicate keys, and they preserve the user ordering of the operations that you pass. So the order of the keys, it's important. And then there are places where we use this kind of information, and this kind of information is important. So for example, like when you do an import, for example, you say, hey, I want only those functions. You may want to say, I want the function map with or reduce with RT2 and reduce with RT3. So there you are repeating the key. And there are other places where I don't want to remember on top of my head, but like Acto is another example of a DSL that uses the fact that you can duplicate things. So we use this feature in a reasonable amount of scenarios. But one of the things that I don't like is that about like using maps for options as well. One of the things that I'm not really a big fan is that then maps starting being used for too many use cases. And the use cases, they are like a little bit overlapping. So for example, when would you use a map today? So, well, when I want to have something that I don't know what the keys are about. So for example, well, something that maps an ID to a username, right? I can have like infinite IDs, as many users as I have in my system. So I really don't know the key. So it's kind of like a lookup thing, key value, general key value. That's one use case for maps today. The second use case for maps today is when I 100% I know the keys. Those keys should always be there. And then using maps as an option, add a third case, which is like, it's something that I know the keys, but the keys may not be there. And I don't like it. I don't like about having those three different use cases, because those last two, they are very conflicting. So for me, it kind of makes maps a little bit like less intuitive, because now I'm going to see a map in a code base, and I'm not going to know if it's something that is supposed to have all those options and never change, or it's something incomplete. And I don't like that. I think like it makes everything so blurry, and I'm not a big fan. I prefer to look at maps and say, oh, if the keys are there up front, I'm like, okay, it's a map. It's always expecting those keys to be here, and that's good. So that's like my official take on the matter. I mean, I completely understand if people would also say, no, we would rather just have a single data structure and use it for everything. And I can see the simplicity in that approach. But, there is also this other side that I'm trying to present here that I think have that has the rationale. And we talked about this literally 10 years ago. Well, not 10 years ago, but almost 10 years ago. It was before 1.0. So, yeah.
Cool, thank you. That was very fascinating to me. I had forgotten about import, like the use case that I think everyone is aware of is, the actor and the query syntax, but also, your thinking about, the basically the incomplete map, where that was very fascinating for me. So thank you very much for that really, really in-depth answer to the question. We'll go a bit of a switch of pace to something else, because it is something that also fascinates me. And I'll tell a little background story, because I once opened an issue on Elixir where it was like, hey, map dot, first calling map and then flatten is faster than calling flat map. And you probably don't remember this, but you replied to the issue within 17 minutes, and you had 2 implementations of flat map that were both faster than the current implementation of flat map. And at that moment I was like, wow, when does he sleep? How much does he do it? So the question is, how many hours do you usually work today, and how do you divide your time?
Oh yeah, that's probably something. So I've recently caught up an arm injury, so that's probably something that I need to work on myself and improve actually to work less. But one of the things that I have been very fortunate is that I've been working remotely before working remotely was cool, for a really long time. And that has always helped me, because I kind of can always be around. But one of the things that I'm disciplined with is that when I'm supposed to be when I'm out of the computer, I'm out of the computer, right? I'm not receiving notifications on my phone. I don't have GitHub on my phone. I don't have Twitter, the app installed on my phone, this kind of stuff. Right, but the reason is that it would allow me to stay a reasonable good amount in front of the computer and kind of be responsive. But the other one is that I have there's also a lot of it is just the timing. So I also don't have notifications for anything, so it's not you open up the issue. So it's just your timing was very good. That's the main thing, because if you open up an issue, I don't receive a notification. I don't get anything on my computer. But it was probably the time the first thing I do, maybe that's not the most productive, but the first thing I do is to check my email when I started working. right? And then I'm going to work on my stuff. And then, well, if I finish a feature that I wanted to do, then I'll go check again. But many times I just like, okay, I check my email and now I'll go deep in this thing that I have to work on. It may take 2 hours, 3 hours, and I'll be focused on that thing, no interruptions. But yeah, so like I'm checking my inbox and then going through the issues like 2-3 times a day, and I think the timing was just But there is also the other thing that I also want to add is that the fastest way to nerd snipe me into anything is benchmarks. I love benchmarks. I love like make things faster. So like when somebody says, hey, like something is slow, I love the challenge. I love the challenge of like somebody say, hey, this is slow, and can we make this faster? For me, it's always very fun. I always enjoy the process of like figuring out what is wrong, how can I improve it, coming up with different solutions. For me, it's like it's very entertaining. I love doing that. So there's also like this personal aspect, like maybe there were like 10 issues in my inbox, but I saw this one. Oh, this one's about performance, and I was like, I'm going to do this first for sure. Yeah. So yeah, that's kind of like how it would go usually when I'm working on open source.
Yeah, I mean, as you know, I love benchmarking as well, like quite a lot. And it's often, it's like playing a programming game, right? You try to increase your high score by making the code faster until you can't make it any more faster. And it's just objectively better. It's in other ways, is this good code? Is this bad code? Does this feature really help the user? It's all kind of subjective, but it's like objectively this one in this use case is faster. So you just know you made something better.
I have the numbers. Right?
Yeah, exactly. Look at them. Oh, wonderful. So, like, another thing that I would like to know about, or a question that was submitted, is you do these use case studies of Elixir, and like, in general, you're very sort of involved in the community. So like, we can see, your commits or like your contributions across many packages. You apparently talk to many companies, and is there a use case that you encountered, like a use case of Elixir where you were like, oh, wow, you're using Elixir for this? Wow, that's really surprising. Was there something like that happened?
Oh, multiple times. I always like to tell like Nerves for me was the biggest example of like people using Elixir for things that I would never have thought about, like I would never have come up with. And that's why when people say like, hey, what should I build for Elixir? I'm like, don't ask me, right? Because if you ask me, it's like, it's if everybody was making those decisions based on what I think, we would not be where we are. So for Nerves for me is always the biggest example, right? Because and I mean when you hear like Frank and Justin talking about why Nerves and why Elixir and the Erlang VM, everything makes sense. And using the writing embedded software and all the companies using Nerves for like all the different kinds of things, like people have Elixir deployed at home because of Nerves, like things related like to controlling electricity, water. I even have a joke, like at an event, somebody told me like, oh, we are using Elixir to control like the water stations in like this whole area in the UK. And then I'm like, don't tell me this. Like, I don't need this. I don't need this responsibility. Anyway, but yeah, so I think like a lot of those cases there are very exciting. And I'm hoping that I will see a lot of people also surprising us with the machine learning stuff and people doing like really cool things that we wouldn't think about it. And that's going to be nice as well.
So maybe on the machine learning stuff. So it's like, so where is it? I mean, there's like lots of people have been working. I mean, a few people have been working on it for quite some time now. And so like, when do you think will we see sort of like the first company, or maybe there is already and I'm just not aware of, that just sort of like it goes all in on like machine learning with Elixir?
Yeah, there is a company already using, I think they are in beta. I'm not sure if I'm going to remember the name, but when this goes up, they can tweet it to it and say, hey, it's us. That is already using some of the machine learning for the prediction stuff, and that has been really cool. But there is still a huge gap. Like there's a lot of work we need to do, because the thing is that it's not only about like machine learning and AI. Is when you're doing machine learning and AI, you need a lot of data. So we also need to improve our tools. We already had some like Flow and Broadway, but we also need to improve our tools for working with like massive amounts of data. That's why it's so much work. And yeah, and there are things that are like started with this effort that are already usable today, like Livebook, right? People are using, like one of the reasons we created Livebook was because we were thinking about like machine learning and like all the experience that people would get around that with trying things out, running experiments, right? That's kind of the main idea of your notebooks, that I want to like run experiments of the data, see like data plotted and get feedback, get insights. And we started Livebook for that, but there are a lot of people already in companies already using Livebook because it's actually great for a bunch of other stuff. And I think slowly we are going to continue to see like specific use cases, right? So one of the tools that we are working on is called Explorer, which is about something called data frames. And the simplest way to think about data frames is like table. Imagine you have tables of data, right? Like you have a column with millions of rows and you want to work on this table. Data frame is going to help with that. And I can see like a bunch of people using data frames, perhaps more people using Explorer and data frames than like a neural network, exactly because of the data aspect. But it's all related to this numerical computing, this ground effort about like bringing all those features and ideas to the ecosystem. And one of the things that makes like it's very exciting for me about all of this is just about like, which is something that I did a lot when I started with Elixir, because a lot of Elixir was like, well, I want to have those things, but how would those things look like if they were implemented in a functional language and the Erlang virtual machine? So it's so nice to kind of like go back to do this kind of exercises again and think about those problems once again. So, work with the community, helping design the solutions. I still absolutely love the fact it has been a year since we announced it that, like we have a subset of Elixir that compiles and runs on the GPU, right? For me, that's just like amazing. And I'm really hoping that we are going to like release the first batch of like the first versions, because a lot of those things are still in the GitHub repository because we are like working on making them stable. And I really hope that soon, really soon, we are going to be at a point like, hey, there is at least an initial version of everything so people can, at least have something that they can try out more directly.
Wonderful. That is fascinating. Yes, that that Elixir can run directly on the GPU. This is something, had you asked me 2 years ago, I was like, no, it's never going to happen, and like, the progress, the technology we make, it's impressive. And so your work and those of all the contributors and all the maintainers of all of that is very impressive, and a continuous joy to just see and be part of that. These surprises come along. It's like, oh, by the way, we're doing machine learning. So, oh wow, okay, cool. I guess I can also do that in Elixir, which is very, very awesome and very amazing. We're reaching the end of our time, so I would just want to ask you, is there anything else that you just want to tell people, like something that we didn't get a question about that you feel like a desperate need to talk to people about, like the dot syntax or something?
No, I think I'm good. We can briefly say about the event. Those who have the opportunity to help and to donate, it will be really awesome if everybody involved can do that and can contribute. Me living in Poland, in Krakow, we have also been helping in other ways, hosting people, meeting people, and helping where we can. So it's both an opportunity to, and I know a lot of people have been doing that, so both an opportunity to to ask for those, with the event now who have the opportunity to do so, and also just acknowledging that the work and appreciating the people who have helped me, for example, and this kind of stuff.
Okay, thank you very much. I think I can sign that statement, and you can go to the website and you can still hit that donate button. I mean, we're recording this right now, so we're not over 100,000 yet, but I would really, really like to see us, hit that $100,000 goal that we could have. So, Jose, thank you so much for taking the time to talk to me, to talk to us today. Thank you for all of your work, and yeah, have a wonderful day. And thanks for all of this.
Thank you. You too. Bye, everyone.
Well, hello there again. Quick change of clothes. Here we are back. And, thank you, Jose, for that really, really great, Q&A session. I hope we were able to answer a lot of your questions. And I hope someday I will be able to answer the question why my cam always loses focus. And I do not know. And I might need to get another expensive webcam to not lose focus anymore. But yeah. Sorry, as Jose said, we're close to 102K. So, some more donations would be great. But, as he also said, there's other ways to help, as I mentioned before. But yeah, we got the question, and, we're heading sort of like towards the end of the day. We got one more talk left, and it's a great talk. Like, I promise, on Toby Honor, it's a really, really great talk. I haven't watched all of it yet, but the parts that I like, the parts that I watched, I really, really liked. And it introduced me to like a new concept, a new wording towards the end. Spoiler. Well, I'm not going to spoil it, but, and I really, really love what Anjana is talking about in her talk. And, for me, it's also, I started writing open source code. We're over 102K. Wow. Okay, let's go 103. Let's do some more. Amazing. But yeah, I also started with open source. Like, I wrote open source code in university, and really was a great way for me to learn. And Anjana actually used to be an English teacher and got into development and dev advocacy. And she'll tell us a lot about this in a really, really great manner. So yeah, I hope she can also help some of you make the jump either into development or into the next step of your career. So, watch this talk, last talk, and then afterwards, just thanks and everything. So, cue video.
Hi, folks. I am so honored and grateful to be here virtually with you all at this super special event. If you haven't had a chance to go to devsforukraine.io/donate, or even if you have, and maybe you just found a couple extra coins between your couch cushions, every bit helps, so please consider giving. Thank you all so much for being here, and thank you so much to Sarah, Cassidy, and the remote organizing team for putting this event together. My name is Anjana Vakil. I am a senior dev advocate at Hasura, coming at you from San Francisco, California. And I would like to talk to you today about opening doors with open source. So as we think about making better futures for ourselves and for the people around us in our industry, really, I think to me what that means is opening doors and creating new opportunities, whether it's for our careers as individuals or for the companies that we work for or maybe have founded, or whether it is for the entire community that we're a part of, because none of us are doing this in isolation. So what I'd like to talk with you all today is about how open source can help create these open doors, these new opportunities for us to pass through and enter a bigger, brighter, more exciting, more successful future. So let's talk first about opening doors for your career with open source. So a tiny bit about me. As I said, I am a developer advocate and a software engineer before I got into dev advocacy. But before that, if we rewind several years, I was an English teacher, not at all had a background in computer science or tech. So what happened in the middle there? How did I get a foot in the door of the competitive, challenging tech industry? Well, around 2015, I encountered an amazing program and community called the Recurse Center. You can read all about it at recurse.com. This is a programming retreat, sort of like a writer's retreat, but for coders, that used to take place in New York City. Now it's virtual, but is a space where folks can come together and work on open source software as a way of advancing their learning journeys at whatever stage of their career that they're at. So there were folks like me just starting out. There were also folks who'd been in the software development industry for decades. And it was a really, really amazing introduction to the tech industry to be in a space working on open source software with a bunch of other really curious, motivated people who were really generous with sharing their knowledge and helping open those doors for newcomers like myself. And so while I was there, I found out about this amazing internship program called Outreachy. If you haven't heard of it, you can check it out at outreachy.org. This is a program that offers paid remote internships in open source to members of the tech community that come from underrepresented or marginalized backgrounds. And so in 2016, I was very lucky to do an Outreachy internship at Mozilla. And by working on open source software at Mozilla, some testing infrastructure for Firefox, I was able to really kickstart my career as a software developer. And without the open source ecosystem around that and the fact that it was a project that was accessible to me as someone of an outsider coming in and trying to learn more about this technology before I had gotten accepted into the internship, this was a really amazing way to get started, because the way Outreachy works is in order to get admission into the internships, you need to actually make contributions to the open source projects you're interested in working on. So this was a really amazing experience for me. And from there, that is how I got started as a professional software engineer. But what I also learned is that sometimes those open doors, they don't always come through the successful moments. Sometimes they come through the failure moments too. So I told you I had an Outreachy internship at Mozilla. What I didn't tell you is that 6 months earlier, because Outreachy internships run twice a year, 6 months earlier, I had applied to Outreachy as well, but I had failed to get in. I was rejected from that round of admissions. I wrote more about it on my very old blog that you can read about there, about what that experience was like. But suffice it to say that even though my first time applying to Outreachy, I didn't get in, I learned so much about making my first pull requests to open source repositories on GitHub, about communicating with maintainers, filing issues, having conversations, making connections with folks who are running these projects. And so even though I failed that round, it really helped me understand kind of the mechanisms of working on software, thanks to the fact that it was all open source and accessible to folks who were doing it, as an entry point into software development. And that helped me then have a stronger application 6 months later, which ultimately led to me getting an internship and then being able to work in the industry. So I also have learned along the way, as I think many of us have, that if you want doors to open to you, it also helps to be open yourself, to be open about what you're going through, what you're learning, your struggles also. And I think there is an amazing concept that has been talked about more and more called learning in public. And if you haven't seen the talks from Codeland Conf, in 2021, Gift Egwenu gave a really great keynote about learning in public, with a shout out to Sean Wang, who has done some amazing writing and made some amazing content on the subject of learning in public. So I highly recommend that you check this out. And suffice it to say that the takeaway from a lot of folks who have made careers in this industry is that by sharing what you're going through as a learner, as someone trying to get into the industry, as someone trying to grapple with a new technology that's maybe different than the types that you've worked with before, by sharing those moments of frustration, those aha moments where it finally clicks, the things that you're struggling with, the open questions you still have, the things you have just learned and just wrapped your head around, that is a really, really great way to not only open doors for yourself, because you're talking about what you're interested in, what you're learning, what skills you've recently acquired, but also to help open doors for the next learner coming along behind you. So in a sense, to open that door for yourself and then hold it open as you're walking through. So please check out Gift's talk and Sean's writing on the topic. Now, the next thing that comes to mind then is, okay, once you're in the industry, you're working at a company, how can open source help open doors and create opportunities for a business as well? Is it just something that we're all working on for free that doesn't really have any correlation with the business world? No, I think the answer we can suffice to say, after several decades of seeing it roll out, open source is also something that creates a lot of opportunities for companies and for material success. So this is evidenced by the immense success in terms of acquisitions and IPOs of companies that are exclusively focused on open source technologies. Folks like Red Hat and MongoDB going for tens of billions of dollars, and even other companies like MuleSoft and Elastic, having valuation of multiple billions of dollars. There is money in open source. It has been demonstrated. And the thing is that, we think sometimes that economic interests and the open source world might be at loggerheads, but I think that we've seen that there can also be a positive feedback cycle between them. So when you're trying to build a product or a service that you want to succeed in a space of developers in software, you're going to be doing some development on that. And if that development is happening in open source, then you're going to have developers falling in love with your product and adopting it because they can try it out without a lot of commitment. They can try it out for free. They can poke around in the code base. They can modify it for their particular use cases. They can communicate with the project team. They can file PRs to add features that they need. They can raise bugs as issues, etc. And so you're going to really accelerate adoption of your product if it is out there in the open for developers to play with. And then, of course, as developers are adopting it from the open source perspective, they're going to start recommending it to their teams to take on in a commercial context. And that means commercial success for your company that's putting this open source software out there. Now, the thing is, if you stop there, and if your company maybe isn't even making the open source software, but is actually relying on open source projects for the technology that you offer to the world, if we stop with just that kind of one directional flow from development to adoption to profits, not only do we have kind of the ethical concern of maybe just profiting off of other people's free labor, of folks who have just donated their nights and weekends to building out these open source projects, but also there's kind of a ceiling put on how much commercial success your company is going to have if that is kind of the end of the line. Whereas if your company invests back into the open source products, whether they're products and services that you're developing within your team, or whether they are wider ecosystems of technologies that your company relies on, investing back into that community, into that development process, lending resources to help make that open source software better is going to drive more adoption because you have better software with more features, fewer bugs, etc., which is going to drive even more success for the company, which means you can put more into the community and so on and so forth. So we get this real virtuous cycle, as it were, a positive feedback cycle through this process. And I think one example of this really working is from the company that I recently joined, Hasura. Hasura makes an open source GraphQL engine that essentially lets you have an instant GraphQL API on top of your data. So it connects to several different types of data sources, databases, other APIs, and essentially offers a instant unified GraphQL API on top of them. And this GraphQL engine is open source, which means there can be a whole kind of community around trying this out, communicating back with the team about what's working, what's not working, contributing features sometimes, or contributing code fixes. And this means that the product just gets better and better, which means the adoption gets larger, which means the company has more customers in the end as they move from using the open source tool into using it in a commercial or professional enterprise context. And at the same time, this GraphQL engine is founded on two other open source projects and communities, GraphQL, as is perhaps evident, and Haskell. The engine is written mainly in Haskell. And so these two projects, Hasura has also been reinvesting in. Why? Because, well, as these two projects advance, so does the technology that Hasura builds that is on top of these projects. So by reinvesting in these communities, reinvesting in the folks who are maintaining these technologies, reinvesting in folks who work with these technologies to improve the processes, to improve the Haskell compilers, or to flesh out, prospective features and proposals and things like that in GraphQL, that means that contribution into those communities is ultimately going to cycle around and come back to the company and its business motivations. So you can read more on the Hasura.io blog about Hasura's work with the GraphQL and Haskell communities if you're interested in hearing more details about that. Another great way that open source can open more doors for your company is when you make the materials, for example, your documentation, your tutorials on how to use your products, open source. That means that the community of learners who is trying to grapple with using your open source product can also contribute back to those materials and help make it easier for other learners to come along and get to know the systems that you've built and the open source tools that you're hoping folks adopt more often. So, for example, at Hasura, we have this series of tutorials at hasura.io/learn. There are some really great tutorials on general concepts such as introduction to GraphQL, or database tutorials, or tutorials about using GraphQL in various front-end frameworks, and of course some tutorials about using Hasura's open source products. But all of these tutorials are open source and freely available on GitHub. So when you're taking a course, like for example, this is the Intro to GraphQL course that we're looking at here, you'll see an Edit on GitHub button on each page of that tutorial. So if you find something that's confusing or could use a little more explanation, you can raise that as an issue on GitHub. If you see a typo or a sentence that's worded in a maybe misleading way, you can fix it. You can submit a PR. And in so doing, you can open the door for more folks to have more success with these tutorials, which also means for the company, by opening up these materials, the community is able to help each other out and make it a better learning experience, a better experience of using the documentation, etc., for other folks in the community. And by that same token, it's a really great way to have your content reach a wider global audience. For example, you'll notice here that these tutorials exist not just in English, but also in other languages like Spanish, Chinese, and Japanese. Some of these being really recent additions, and all driven by the community. So when you make the documentation and tutorials around your products open source, you can have the community itself help you reach a wider audience, a wider net of developers who might be interested in adopting your tools. And that, of course, is going to create more opportunities, open more doors for your company and the business that you're trying to run. And that's because I really think that, it's cool that we build software. Like, that is a really cool thing. And even better, I think some of us might agree, than building software is building open source products. But the really galaxy brain level here is not building products, whether they're open source or not, but building community around the tools that we use. Because when you're investing in a community, you are investing in the sustainability of those tools. When there is a community surrounding an open source project, that is going to make it survive past the original creator or the original maintainers. And when there is a community around the open source tools that your company either puts out there or relies on for the proprietary technology that you build, by investing in those communities and supporting those communities, you are supporting the foundations on which your company is going to be able to have success. And strengthening those foundations is going to create more and better opportunities in an economic sense as well. And so that brings us to the last kind of take I want to think about with you all here, which is how we can open doors and create more opportunities for the communities that we operate in as developers and as humans. So I don't know if folks have had a chance to check out the GitHub Octaverse reports. The state of the Octaverse reports that GitHub puts out are really fabulous look at open source ecosystems and open source developers, and have some really excellent takeaways that we can apply in our own projects and in our own communities. So in their latest 2021 report, one of the focus areas that they reported on was supporting sustainable communities. And in light of supporting communities, they laid out several observations and, in a sense, recommendations for how we can support communities in being more sustainable over time in the open source world. So I just want to take a look quickly at a few of the points that they raised in that report. And you can check out all the details at octaverse.github.com. And before we go on, can we just take a moment to appreciate this statistic? So in the 2021 State of the Octaverse, they found that there are over 73 million developers on GitHub total. But what I think is truly amazing is over 16 million of those are new users in 2021. Now, that might not mean that all of these people are completely new to software or to open source. Maybe they're just new to GitHub as a platform, but even so, that is a huge chunk of the developer ecosystem out there in the GitHub universe that is brand new. So we should be thinking, how can we make more opportunities for a community that has such a huge proportion of newcomers in it? And one way that GitHub pointed out is a really great lever for helping a community be sustainable is mentorship. So they point out that mentorship is a community asset, both in open source projects and communities and within companies as well. And so Outreachy, for example, which I told you about earlier, the internships that Outreachy runs are all mentored. So as an intern, you have a dedicated mentor who is there for you to ask questions, there to give you guidance, there to help you get unblocked. And that mentorship relationship is what really makes it such a pleasant and fluid experience to pass through that open door and get into the new project or new field that you are working through. And for example, when I participated in Outreachy at Mozilla in 2016, my mentor, Maya Friedrichowski, had been an intern herself several years before, and so was able to kind of pass down that gift of mentorship or pass it forward, as it were. And so that's something we can all be thinking about, is how can we contribute back? How can we, if we have time and expertise and we have a willingness to support the community, how can we help mentor others? And how can we also position ourselves as mentees to find new opportunities by talking to different folks, perhaps further ahead in their career or perhaps in different fields that we can learn from? And so I recently learned about another really great initiative called Tupu. Tupu.io is a mentorship network that aims to offer free mentorship to folks from marginalized communities, such as women, people of color, and LGBT folks. And so this is a network that you can join either as a mentor or as a mentee, or both. And so if you are interested in joining a network of folks trying to give back and make more connections through that mentorship relationship, check out tupu.io. Okay, the second point that was raised in the Octaverse report is that trust and respect contribute to a really strong culture. In open source, I think it is really important because we have this, hugely open project that is accessible to folks from all over the place with all types of backgrounds who are coming at it from all different perspectives. It's really important to have some foundation for building that trust and respect so that the community can be sustainable. And so having a code of conduct for contributors or some kind of ground rules for how your community should interact and how interactions around everything from pull requests and issue discussions to meetups or in-person gatherings or virtual gatherings, having clear rules of the game to ensure that trust and respect is really important. So if you haven't seen Contributor Covenant, this is a really great project that offers a open source, open license code of conduct for open source communities. So it's a really great starting point. If you haven't implemented a code of conduct for your community yet, this is a really great starting point. So I would highly recommend any maintainers out there or folks who are working at companies where you do have open source public facing projects to check out Contributor Covenant if you don't already have a code of conduct or contributor guidelines in the social sense to ensure trust and respect. Please, please, please add those, and Contributor Covenant is a great way to start. And the last point that I want to talk about from the Octaverse report is essentially that the safer and more welcoming a community feels, the more comfortable and the more attracted newcomers are going to feel. And that means the more contributions that project or that community is going to get. So basically, the more that you make your project something that even somebody brand new can come in and contribute to, the more sustainable and the more successful that community and that project is going to be. So there is a really great project called Open Gates Checklist. You can check it out at opengates.dev that essentially provides what they call an anti-gatekeeping checklist. And it is geared towards content more generally, but I think it totally applies as well to open source projects. And it is a really great way of kind of ensuring that you're not doing things or instituting practices or using language that can make newcomers not feel welcome or make folks from different backgrounds not feel welcome. And so by running through a checklist like this, or maybe you make your own checklist from the learnings you've had from your own community, by making sure that you are evaluating how much your language and your guidelines and the tone and the content that your community and your project is putting out there, by evaluating how much those are welcoming and not gatekeeping, you can really ensure that you have a more sustainable, more successful project and a more successful, sustainable community with more opportunities created for the folks within it. Excuse me. And that's because this notion of gatekeeping, I think we're really past it. This notion that you have to be, some sort of wizard or expert in order to participate in open source, or that if you don't have 10 years of experience with this technology, you can't make a useful contribution. Those gatekeeping notions, we're done with. Drake is done with them. Instead, we should be thinking about how can we not keep these gates up, but rather break them down. So instead of gatekeeping, let's try to focus on gate breaking, on really making sure that these gates come down once and for all, and that again, for every door that we open, we're holding it open for the folks who come behind us to walk through as well. So that is it for me. Thank you so much for being here with us today. And again, huge thank you to the organizing team of Devs for Ukraine. And again, please make sure if you have the means to visit devsforukraine.io and give whatever you can. Thank you so much.
Well, thank you, for that really, really great talk. And, I love gate breaking. I said, I have a new favorite word and a new favorite concept from this talk, and that is gate breaking. I just love that because, smash that shit. But yeah, so this brings us to the end of not just the evening, but also the entire conference. So I want to thank you all for donating. Thank you all for coming here. And well, I also want to really, really thank my, co-organizers. We have Cassie. Hi.
Hello. I'm so glad that we pulled it off. And thank you everybody so much for donating. This has been truly a labor of love, and we've been just kind of frantically getting things done behind the scenes. But check out that donation amount. That is so, so amazing. The fact that we wanted to initially raise 15 grand and we got this much is truly incredible. And thank you all so, so much.
And also, really thank you, Sarah, because I said it before, but really Sarah is who kicked all of this off, which is why.
No. You're making it weird.
No,
You're making it weird.
you
I'm
did.
Right here.
You
You're making-
went to Cassie and you were like, let's do this.
No.
Yes.
So anyway, this entire conference was Sarah's idea. Sarah, she DM'd me like in the middle of March. Oh, there she goes. She DM'd me in the middle of March saying, hey, do you want to do a conference? And I was like, yeah. And somehow we managed to pull it off. And she worked on the website. Our teammate Adrian designed these beautiful designs that you see on the Devs for Ukraine website. And then between all of us and our CTO Marcelo, we gathered all of the amazing speakers. And oh my gosh, the talks were so amazing throughout the past few days. And then it was just a constant, we got to get stuff done as we edited all the videos and we made sure the Twitter accounts were set up and the Twitch accounts were set up and we got it done in the end. So thank you all so much for being here and making it all worthwhile. The fact that, again, we donated so much is so, so exciting. And thank you all again for being here.
Also, Cassidy is a freaking wizard, doing all of these banners and everything. Yesterday we were trying to moderate and Cassidy was faster to moderate people while she was speaking. So like having the best producer in the game is also like a really, really good thing to have.
I have a major newfound respect for event producers because this has been stressful.
Hasn't it been? So I think we should say thanks to all the sponsors once again, who also put in major money. I mean, thanks to all of you who donated money, but we also had our major sponsors, which were Frontend Masters, Osis Capital, Incredible Dev, Linode, Akami, Stripe, and of course also our own company, Remote.com, making it possible so that we could take our time and run this event with you for all of you, which I hope you all really enjoyed, and you will tell your friends about the video on demand, because everything is recorded, and then they see everyone saying like, hey, donate more money, and there will be more money. Hopefully.
Yeah, the talks are already on YouTube. This is how Cassidy works. During the talk, she was
frantically uploading
and uploading stuff to YouTube.
But yeah, the talks are online now, and if you go to at Devs for Ukraine on Twitter, we have tweeted out the playlist, and I'll tweet out the playlist as well, and you'll see it, and you can see all of the amazing talks that were happening yesterday and today.
I think that's
I think that's
We're making it weird. We're making it weird.
We're
Let's
free
get
to
out.
go, and we can finally sleep.
What is sleep?
But my fame, now that I'm on camera, I don't want to let go. No.
You're an influencer now, Toby. You got the bug.
You're a star. You're a star, man. And your internet didn't fail. Last race for Toby's internet.
Yeah, very big applause for Toby's internet because that was a major question mark throughout the tests for this event. We made it. Okay, everybody.
See, how did she write this as talking? This is kind of what I'm saying. Like her
mechanical
eyes didn't move.
keyboards.
Yes, let's get into keyboards later. Okay, everybody, I am going to shut this down. We're all going to take a nap. If you want to hear more from us, once again, we are on the internet. And so you can find us at Devs for Ukraine. And I've been just kind of retweeting all of us from that handle throughout. You can find clips of the talks. You can find the YouTubes for all of the thingamajigs. And yeah, we'll see you next time.
And just quickly, sorry, thanks all the speakers also for making this happen, really on this short amount of time. Like we called it talks and everything. So without the speakers, none of this would have happened. And really a lot of them really produced these great high quality talks, gave them for free for the cause and for everything. So really, really want to thank all of them because, they were what made this go. And I really enjoyed the talks and will rewatch some of them. Oh, well, probably all of them. Thank you very much.
All right. Thanks, everybody. I'm shutting it down. I'll talk to y'all later. Catch you on the flippity flip. Bye.
Bye.